1, 2, 3, okay. Welcome, everyone. Please be seated. Welcome to the first User and Developer Summit for OpenZFS, and welcome to Portland for those who are not local. My name is Michael Dexter, and last year, Matt put a big old top to-do item on the developer list of the spreadsheet, like, let's figure out how to plan the conference and make it a little easier for them. So somehow I volunteered to jump in. I hope you've enjoyed the food so far. This is a summit, not a conference. And some of the dads out there will recognize that artwork. So conferences generally have a ticket price of, say, $1,000 or more. They have $30 really dry sandwiches that cost the organizers a fortune and aren't very good and are very carb heavy. They famously have the $10,000 coffee break at the convention center. And my thinking is, over my dead body. They generally have miserable booth staff missing a soccer game. They have occasionally $15,000 AV rentals, with which hopefully you end up with some videos but no hardware as an organization. And they have lampshades on people's heads, and you can look that up if you like. So basically my policy on this is over my dead body. And as Rob Norris put it in a conversation, he's like, well, wait a minute, what if we just took an event and only kept the good parts? And I'm like, yes! So here we are, welcome. So the rules very briefly. We are subject to the OpenZFS Code of Conduct that I believe is posted by the door there. It is very reasonable. It is largely be respectful and be patient. And take a peek, it's quite good, one of the best I've ever seen. We have a licensed bartender in the state of Oregon and Washington, 24/7, who will assist with anything alcoholic and will send you back to Washington, where he's also licensed to walk your way back if you get out of hand. We have a first responder, maybe emeritus, but within our reach, who's smiling in back there. So if anyone has an issue of any kind, please reach out to myself, a show of hands, actually myself, Stu, Santi, Patrick, Rod. We're all here to help. Andrew and Lisa fresh in front. This is one of the greatest teams I've worked with, but I'll get to that in a sec. Please clean up after yourself. We're going for what I learned in kindergarten ones. Please don't abuse the network. It's not been fully exercised, but so far so good. It is here in the Oregon Latvian Center. It is powered by Mikrotik devices. We can talk about that ping of death later. Please help each other, be it physically, be it cleaning, be it making that sandwich, be it with that code review, all of the above, all of it. And Multnomah County law says you should be quiet by 11, but the keys to this facility are in my pocket and Rod's pocket. If you want to hack all night, hack all night. There is no shower here, but if you need to head back to the hotel at 6 in the morning and quickly clean up, do it. You are absolutely free to make yourselves at home here. The Wi-Fi, there are some signs on the walls, but is OLC for the Oregon Latvian Center, and I had to do 8 characters, so I threw the proper J in Latvia. Capital L, J before A, exclamation point, Latvia. Nom nom nom. I mentioned sandwiches at every conference you've been to. Anyone been to BSDCan? And remember those, yes, show of hands, those sandwiches that every day we had. So hopefully you have never heard of any of these places. They're all local. They're some of my favorites. We will have catered lunches every day. And tonight we will have an Argentinian barbecue, and Monday night there will be a southern barbecue. How would you like to describe that, Stu? Pulled pork. With vegan options at every turn and gluten-free options at every turn. So what is a Latvian and why are they centered? Welcome to the Oregon Latvian Center. The diaspora is the 4th region of Latvia. We are around the world, from Melbourne to Indianapolis to Toronto, you name it. We invented the Christmas tree. We invented the Minox spy camera. We have the widest waterfall in Europe, and we like to sing and dance. And there's a piano up here if you need it. I can bring an accordion from home and some kuoklas, whatever instruments you need, plus some electric guitars, you name it. So we sing, that's on this stage. My wife and daughter are hiding up there, and award-winning composer Lolita Ritmanis is hiding back there on the piano. We like to sing and dance at the same time. We sometimes get together every 4 years to bring 40,000 of your best friends to sing together. My wife and daughter are hiding up there somewhere in the white band almost, or just above it. That's a selfie at that same venue, the open air park in Riga. And if you're wondering about that little logo on all of the swag, that was the White Stag sign, a sportswear producer here in Portland, Oregon, and that sign has had many changes. It's gone from White Stag to Made in Oregon to Portland, Oregon, welcome to Old Town. So you will see an OpenZFS with Bambi on top. The thank yous. Above all, huge thanks to Delphix by Perforce, invaluable supporter from day one of this event in its, 14th year now as a developer summit. They came in as a diamond sponsor. Thank you, gold sponsors, Creative Space at OS Nexus. I believe we will have representatives of both. Show your hand, Stu. It sounds like we've got Stuart of Creative Space at Digital Glue. Ask him anything, and I think the OS Nexus folks will be here over the next few days. Thank you, silver sponsors. We have TrueNAS. Thank you, Mav. Thank you, FreeBSD Foundation, who came in as a bronze sponsor. And some will get this reference, some will not. To quote Miller, air is good, don't you think? Air is nice. The folks at the Software Freedom Conservancy, whom have a rep here in town, actually 2 in Oregon, kindly donated the Fosse air purifiers. And we are trying to balance everyone's needs and interests. So we've got air filters around the room. Let's verify they're on. We have masks in back. I've got some COVID tests in back. I want everyone to be comfortable. We can open up this door for yet more airflow. Sorry about the rain, however, it keeps you focused and not at the beach or on the mountain. And as part of this, Conservancy would like to simply say, hey, we encourage you to become a sustainer, 10 bucks a month. That would be appreciated. It's difficult to be a nonprofit in this current economy. And the oh my gosh, thank you. The crew who is in various corners of this room right now. Matt Aarons and Karen, who helped organize this for the last 6 months or so, technically a year, thank you. Stuart and Santi, our kitchen crew and pit crew for the grill pit. Nick, who helped out, he'll be here Monday. Lisa and Andrew, who might be in front there, but they're missing their thanks. Thank you, Lisa and Andrew. Rod Grimes, very helpful yesterday. Thank you so much. And Patrick, our streaming expert that we flew in because we realized in the context of all the different budget sizes thrown in the vague direction of streaming, we found a sniper shot to do it well with our own hardware with a trusted party. And no 15-page agreement on signing over your entire career to the company streaming. I have a great picture of Kirk McCusick in Ottawa laughing at the agreement, like, go to hell. Anyway, off topic, sorry. So, thank you, production users. I believe there are a few in the house. Mav, you've joined. Pat, you've joined. You've been very active, Stuart. We've got Andrew Hedinger. So, one thing led to another. There were beehive calls for the developers discussing developing stuff, and we discussed reviews, which patches, questions, you name it. And then we'd spend 2 hours discussing ZFS. Because, strangely, every beehive user is generally a ZFS user. So that blossomed into production user calls for beehive. That blossomed into production user calls for jails and containers and zones on Illumos. We very much are Illumos and FreeBSD focused, and then eventually ZFS, because suddenly every conversation ended with ZFS. So those are Tuesday, Wednesday, Thursday. Check out callfortesting.org for more information. But that chemistry has inspired much of what will take place the next 4 days. We found that taking months to discuss a topic and refine the questions, refine the answers, refine the whatever, has produced some amazing things like the Zelta backup tool, which was used by a production user, and it was gently served through the fence instead of thrown over it. And Daniel's been a delight to work with, and if I'm not mistaken, someone in the room described it as the best backup tool they've used in their career, so I'm going to stick with that. Thank you, kitchen crew. It was quite the adventure yesterday with our 2 shopping carts at Costco and a full van, and this is after I was already doing a full van of beverages. And there's our streamer extraordinaire. Get off your phone, Patrick. So Patrick has been pounding his head against every little thing. How do we get the Zoom to sync to the thing and not get hum and all the things. So there's a lot going on here. Thank you. Then the why. We can have nice things. It's not often, but in tech, we can sometimes have very nice things. I consider ZFS a very nice thing. It does a lot of heavy lifting, and we often take it for granted. And it's amazing. Thank you, team. Developers will be trickling over the next few days. Thank them, please. They are very nice people. They are very, on average, very, very nice people. And Matt, the team lead, is a delight. Thank you, Matt, in advance, and he'll probably roll in tomorrow. And the result is the nicest feedback loop I've ever seen. Name a huge vendor who for very little time and effort you can get like features refined or added or documentation fixed. If I say Veritas, will anyone have scars and think, oh yeah, we gave them like millions to fix this one thing? Well, in open source circles, magic can happen, and I think OpenZFS is one of the greatest pieces of open source software available at any price, regardless. So, engage and enjoy. This is very participatory. It's a bit of a hybrid of unconference and moderated discussions based on the calls, and I last night had to shut people up and like save it for the discussion because we're all kind of pent up on a lot of topics, and there's some good stuff that's coming down the pipe. There are restrooms out and behind the kitchen. There is a drinking fountain, like airport style with the filter and all the thing. We've got some water directly from it in a pitcher there. We've got swag. We've got glasses that I'll probably get some boxes for so you can throw them in your luggage so they're a little safer. We have mugs. And selfishly, most of the mugs of the world have a logo here. We are here to promote OpenZFS. So cheers, there is a logo on end, like Matt Aaron's last year. Either prayer emoji or high five emoji. So yes, everyone, cheers. And let's see, masks, All of the mugs and glassware you find in front are clean and ready to use. You can put your name on blue tape with a Sharpie and call it yours, and we can even wash it for you. Then we'll probably just swap them around. The tape is there, thank you. Any questions? Well, thank you everyone. Welcome to Portland, and let's do this. Welcome back, everyone. We will begin our first moderated sessions now. And we have at least 2 amazing heavy lifting developers in the room. And you'll notice that the User Summit comes before the Developer Summit. And we've been discussing topics on the calls for months, if not years. And it is my sincere goal to craft a handful of topics that are very well researched, very well thought out, and present them on a silver platter to developers, potentially with a budget from your vendors. So we'll get to those nuances later. But this first topic is inspired by some issues that dRAID found. And Alan Jude might have some comments to contribute, having been part of that process without naming any names. But the name I pulled out of thin air was Project ZeroFault. What OpenZFS level safeguards can we provide to avoid pool faults and offlining and suspension is the word I'm looking for. So, regarding warnings and safeguards and all, some of you may recall a rather public cry for help from a popular YouTuber who ran proudly on their ZFS system with 0 warnings set up, and it went off a cliff because they never thought to check in on it. I'll let you do the research on that one. So a few topics that came up in the course of this is that every OS has some form of mechanism to provide 1, notifications, 2, occasionally things related to ZFS. So if, for example, you're on classic Solaris or Lumos, you have the fault manager and a very sophisticated integrated fault management system. On FreeBSD, you have ZFSD, which came out of a vendor long ago and has been out in the open for quite some time. On GNU Linux, you have Z, the event daemon. And on appliances like TrueNAS, you have a sophisticated set of email notifications and checks and warnings and red lights and blinky and sometimes a hardware light in front that warns you that things are not as perfect as they should be. And yet, despite all of that, various folks in the room have seen pools fault and suspend right, left, and center when people set it up years in advance. A hand just went up, and I'll put my hand up. Despite all these tools, if you don't set up the warning mechanism, you will not receive warnings. There's a deep, profound statement that you can take to the bank that will save you a whole lot of time and money if you just take that one step that hopefully it warned you to do. So here we are. So that said, and Alan, if at some point you want to talk about Don's encounters on a painful thing, which will set further context, but I'll punch to the ideas. Maybe you can chime in, and then we've got hands that have already gone up. So, so far, we all know that, say, RAIDZ can handle up to 3 spares, and perhaps there should be some behavior. I will not speculate at this very moment, but some behavior prior to achieving 0 redundancy. And everyone in this room has a different workload. Some of those are databases, some of those are write-only logging, some of that's, you name it, all the things. And I guarantee for everyone here with their workload, they're not aware of someone else's workload. So if one person says, we can solve that by just going into read-only mode, someone else will say, heck no, that would do terrible things, but maybe we could do this. And that's the kind of conversation I want to have. Having, for some workloads, a pool that gracefully is read mostly in times of danger, allows you to heal and works its way back, is tentatively what sounded attractive, but we could be all wrong about that. Now, OpenZFS is probably the most portable file system after FAT32. Name any others, I'm curious, I'd love to hear it, but that may be ext something, but that's still a challenge on any given OS. And in that is a whole lot of lifting by OpenZFS. And I'm grateful for that because you get that heavy lifting on every platform for free. It's great. So that's the crux of how any resources and mechanisms within OpenZFS that you get for free on every platform is a very good thing from a user perspective. And let's see, over the years have been discussions like, well, should there be any notion of, say, device health checking through smart or other mechanisms? Remains to be seen. And again, the real world notion of read only, read mostly, what is a graceful, oh, I'm so glad it did that, as opposed to, oh no, it did that. All of which is preferable to faulting, so there's that. Now, story time. Every time I mention this, there's a story that comes up from each user, so we can either lead with that if you like, or ease into it. What's that? Yes, actually these are wide open. I will post them to, or what I'll do is post an aggregator where they can all be had from. Okay, yeah, I'll take care of that at the moment. I've got a free sec. Sure, and you're actually welcome to blast right into there. So as we kick into maybe some story time, I'll get them up there. Very good point. And whenever you see me doing something on a call or whatever, the documents are wide open. It's your doc, with that number 8. Drop your story in there, because geeks can be very quiet by nature until you hit a landmine, and then they won't stop, and then you say magical things, and I thank you for it. So there's that. Developers, engineers, and administrators, not geeks, sorry. So Jan from the calls mentioned, hey, drives will lie to you in every which way, which is something I believe Mr. Juden led with in his signings of books, because devices range in quality from terrible to horrible to great to whatever you name it. We all have our stories there. Various latency behaviors to watch. Let's dive into that as a topic if it comes up. So go ahead and Patrick, let's kick to the group, kick to the main video, and I'll work on getting slides to everybody. Because you can blog at the end of this document. Just punch it right in there. Thank you.
Yeah. Okay. Especially on the topic of the latency thing, I think one of the things Don's going to work on at the hackathon is he has a prototype for RAIDZ where we keep track of the latency of each disk. And if we find one that's a large outlier, so not necessarily, like right now, ZFS can detect slow IOs, but that's an IO that takes more than 30 seconds, and it doesn't generally blame the individual disk to it, just the whole ZIO itself. But basically, we'll detect the outlier and then look at using the RAIDZ parity to reconstruct the block and finish the read without waiting for that disk. So if there's one disk that's significantly slower than the others, then we will just use parity and reconstruct the data and not subject the user to that latency. And we can kind of start tracking those as slow IOs on that disk and decide to maybe replace it using the Z or ZFSD mechanism. But basically keeping track of the outliers in latency between the members of the same VDEV. And it also gives that disk a chance to recover. So if a disk is slower, maybe it's an NVMe that's overheating and so it's going slower, it will notice when it comes back and then stop treating it as, you know, a stepchild. And so it looks quite an interesting way to solve that problem, to A, detect it and be able to raise events that your fault manager can decide to do something about, but also give ZFS the ability to decide, let's just use, you know, we've issued all the reads. We don't normally issue the reads to parity, but this disk we know is slow, so preemptively we're also going to maybe read the parity, and if that comes back first, then we can reconstruct the data and give the user the read they were looking for without having to wait for the disk that's going to take 3 times longer than its peers.
I wonder how in that case handle shared buffer. When we're reading from several disks, we're reading practically in the same buffer, and we cannot complete the IO, we cannot free buffer until all of them return. Otherwise, memory will be reused, and that's typical problem with all kind of timeouts. Sure, we can later, for later IO, just to skip using the disk, and that will work. But question how to handle the situation when we already got stuck.
Yeah, I think currently we already have that situation of, one of the problems with the current slow IO mechanism is we only detect that the IO is slow when it does actually finish, which means if it never finishes, we never detect that it was slow, and we're just stuck waiting forever. ZFS doesn't actually have a way to time out, right? Like it's issued the request to the kernel. If the kernel never returns, ZFS is just kind of stuck there. But yeah, like if we try to go forward without it, then when we do get that back from the kernel, how do we not just accumulate these? And in general, we're kind of assuming that the disk is going to eventually return and we can free the buffer. But yeah, I think Dawn's current version of the mechanism is just when we detect the disk is slow, we don't try to read from it. We just read the parity instead and reconstruct the block so that we don't issue the I/O to the device we know is struggling, hopefully so that it can catch up on what it was doing and stop being a laggard. But
Then question, how do we know that it recovered if we don't send requests?
I think every 100 IOs we send it one or something like that to try to tell.
Do you know, does the administrator know if, in this sort of mechanism, like what sort of visible notice do they get that, oh, well, here's this drive that's going bad? Because
So when you do zpool status -s, it adds the slow column, and we'll increment that every time we have to do this.
okay,
So the
so
problem with that is you have to
it seems
know
like a
to
bit
issue
more
the
urgent
-s.
situation.
Yeah.
Because if you're already in a point where you're relying on parity, then that means you have less redundancy than you think you actually do.
Well, so we're not relying on the parity, we're just choosing to use it because it'll be faster than the slow disk. But yes, we do want to make sure the administrator gets notified, because if this disk is exhibiting this behavior, it is likely on its way to failing, or is having a thermal issue, or something obviously is going on, or some other workload is busying it up, whether it's the smart self-test, or if it's an SSD, if it's garbage collecting and taking a really long time, that's a condition that it will likely recover from in short order. And so issuing additional I/O occasionally to tell, hey, this one's not an outlier anymore, we don't need to replace it. But yeah, it's very early days. We've just started looking at this. The original design was a pool flag that would make you always read the parity, almost like in a scrub, and then just as soon as you got enough columns back to reconstruct the data, to give it back to the user. But I think Dawn's newer idea is much cleaner and has less buffer management issues than the original design that was just always read the parity, because that also has costs and impacts all the other I/O, right? If you're keeping more disks busy for each read, you're making every read more expensive and reducing your available IOPS.
Just a thought to mention, it was brought before, but just in the context of disk latency for failing disks, we should at some point bring to order at least Linux functionality of do not retry, low retry.
Fail fast?
Fail fast, right. I don't think right now we're doing it very reasonably, because if we know that we are redundant, we're reading from RAIDZ, we should, and it's redundant, we should try to do fail fast first. Then if we fail, we could retry, and then we should try hard.
Yeah.
But otherwise, like it would by few times reduce the timeout, hopefully.
Exactly. And less likely that we get this, the kernel just takes forever to return and ZFS gets stuck.
It should probably be ported on FreeBSD too,
Yes.
and it should not be difficult, I don't think.
Yeah.
Did you say that showed up under status S?
Yeah, so zpool status -s adds an extra column to, so normally you have read errors, write errors, read errors, checksum errors. Yeah, and when you add -s, it adds a slow column and shows how many of IOs have been slow.
So that's zpool IO stat.
No, this is zpool status -s.
I've
so it
never seen that one.
Okay.
I haven't either. I just ran it on my. Show it to the next one.
It came with 2.0, I think.
Okay.
And so it adds a column that shows slows, and it just, maybe the whole conversation we need to have later today is about, in general, we always add new functionality behind a flag so that we don't, break people's scripts or start using new stuff. But at some point, maybe we should change the default to include more of this useful stuff. I don't know about the slow I/O in zpool status necessarily, but for ZFS send, our default set of don't use any features is probably detrimental to what we should be doing. And maybe what we want for ZFS send is like we have now for zpool create with the compat equal stuff. And we set like a default level for compat. So, if you're using OpenZFS 2.3, the default is being compatible with 2.1, or maybe we decide that whatever the oldest Ubuntu still supports or whatever, what the longest long-term support that's still active is. But, you know, disabling compression by default and embedded blocks by default because, you know, the remote pool might not support LZ4 because it's from 2007 doesn't seem to make sense anymore.
What I'm getting at is, I know, at least personally, I would rather see that in a, I mean, not rather, but I would like to see that, at least a warning of that when I do a -X. Because that's usually what I'm looking at for error, for any kind of errors
Right,
or
but
problems.
-X also doesn't show you even if there were checksum errors, right? It's only if the disk, if any disk is
No, it'll show checksum
degraded
error.
or faulted,
Well,
right?
wait a minute. No, you're right.
Is it,
It won't.
only if any disk is not healthy.
You're right, because it's not defined as not
But
healthy.
maybe we can add an extra letter or two or something.
Yeah, so, excuse me, so just from a monitoring perspective, you know, I really want to see anything that suggests that maybe this pool might not be healthy
Right.
reflected in the state. Because that's the thing that I actually monitor at the highest priority is what is the pool status.
Yeah. I don't know if we were smart enough. Does the JSON output include all the columns by default instead of making you pick and choose? I don't know. The zpool status --JSON is new, and I don't actually know what columns it includes.
We had a JSON output?
Yeah, so, I mean, so.
So
yeah, my
2.3
monitoring
RC2
tools are
includes JSON
just looking
output
at-
for zpool status now.
Yeah, so
But,
I'm not likely
okay.
to rewrite my monitoring tools, so.
Right. So 2.2 does include the VDEV properties work I did where you can do zpool get slow IO pool name disk name or all -VDEVs to get every disk. And you can get structured output that you can easily parse for a monitoring tool to show any of the columns that were there. But yeah, the JSON output now should also make this a lot easier to feed into a monitoring system in a way the monitoring system probably assumes will work. Or, you know, Prometheus will just take the JSON and put it into your database for you.
3 very quick points of order. One, for anyone who's been on the agenda doc for the calls, go to CFTLV as a short URL, call for testing. This is that doc. Jump on the appropriate specific doc like ZeroFault or any of your notes. Just blast them in there somewhere. Put your name by them if possible. Number 2, is there anyone up in front who's not wanting to be streamed because we could turn the camera over and have some of you and your smiling faces on the stream? If you want. Anyone objecting to being recorded or streamed in any way, shape, or form? Anyone? Anyone? Cool. And finally, on the very topic, as the dust settles on things like JSON output and your structured output and a lot more informational output, the whole notion of changing the defaults when you have this like decade cache of regex that you use to parse the output, that can hopefully all finally go away, and changing the default will not be painful because you're just specifying fields to report, etc. So whomever's worked on that, thank you.
Or have an original flag.
Yeah.
On your machine? The agenda. Continue.
Yeah, so maybe coming back to the earlier topic you mentioned about, what was it about? What was the first thing you asked me about during your talk before we got to slow IO? Suspending the pool before you run out of redundancy. Yeah, that one happened on the last ZFS leadership call that I wasn't able to attend. But yeah, so, you know, one of our customers has like a write mostly workload, and they ran into an issue where Z had gone kind of off the reservation, and every disk was marked as degraded, and 3 of them were faulted, and there was a replacing that was happening, and the new replacement drive died during it. And so there was, new writes were not getting written quite correctly. And so they wondered, you know, if we were running a 14 wide RAIDZ 3, if we're down to, you know, 2 disks already, we'd actually rather have the option to suspend the pool at that point and not write any more, and our clustering system will send the write somewhere else instead, and know that we're not going to have written anything that we won't be able to read back later because of additional failures or something. And I think that's a reasonable thing, obviously not as a default, but maybe as a zpool property, you say, you know, if my redundancy gets below this threshold, then I want to suspend the pool rather than continue and risk, you know, the data I write not being able to be read. Mostly, the pool should have suspended in the situation that was in, but a bug in the way Z and zpool work together meant it didn't suspend when it probably should have.
But if your application anyway has to know about those write failures because of suspension, wouldn't it be much nicer and cleaner to handle it out of the band? Just report, okay, this pool degraded up to a certain level, report to cluster or whatever that this node should be used with lower priority. Keep it functioning, but just move load out of it. Because freezing is just such an extreme measure that you don't really have way to recover from it, and a lot of pain goes after.
Yeah, I guess part of it also depends on the cause. If it's actually failed disks, that's one thing. But if it was, you know, the SAS fabric rebooted or something, and you kind of just lost a lot of disks all at once, but, you know, when you zpool clear, they'll all be there again, then it's a little different. But I do see your point that maybe, you know, there's a way outside of ZFS to handle this, or even just, you know, when you get the accumulation of those faulted drives from Z, that they could trigger something outside. Especially since, as you said, if we're going to auto-suspend when we don't have enough disks, if zpool clear is just going to release or lead to us suspending again right away, then it's like, how do you actually get out of it, right? Especially when it's suspended, you can't, you know, issue, replace, and so on. And I think on the call they talked about maybe forcing it read-only, but then you have the problem of, well, you have these pending writes that are, you know, async writes that are waiting, and I guess we just have to sit on those forever, and then either
Let them drain.
depending on your fail mode, if it's wait, then anybody that tries to write, the write call will just block. We did make some improvements to fail mode equals continue, where it will actually return errors to the stuff that was in flight even. So if you've called fsync and then the disk suspended, instead of that one being a wait, we'll actually go and cancel all of those and make the fsync fail, so the application actually knows that the write isn't going to have worked. But maybe that's not enough. And same problem with if you force the pool read-only, what do we do with what's in flight, and what do we do with any new I/O that tries to come in? You know, we can immediately reject any new writes that try to come in because we're read-only now, but all the stuff that was in flight is kind of in this indeterminate state, and that's maybe not the best thing for it. Especially if, you know, your only other option is a forced export, which is a feature we still haven't actually finished, that's going to throw away all that pending stuff and just let you roll back to the last transaction group that did complete.
Yeah. So my users are graduate students, and I have found that automating graduate students is actually really difficult. And so I actually like the idea of just suspending, because when their stuff breaks, they actually notice. If they've spent the past 4 days writing into a full file system, they do not notice. They probably aren't even watching the output of that job. But when they don't, you know, when they get it, you know, when their job finishes and it finishes with, oh, there's an error and nothing actually worked, then at least they start to complain, and maybe they might ask what's going on sometimes.
Yeah, but that gets back to Alexander's point there of that if the default fail mode is wait, then when they try to do something, they won't get an error, it just will never start or finish. It'll just hang forever, which maybe will at least get some attention, but it comes back to Dexter's early example with Mr. YouTube guy who didn't monitor his pool, and if it had suspended, they might have noticed sooner than.
Yeah, it's like, I mean, in my situation, like, monitoring the pool is my job, it's not their job.
Mm-hmm.
But, you know, at least when their stuff doesn't work they notice and they usually complain. I mean, sometimes they don't. Sometimes they set up a whole shadow IT operation. But
Yeah.
you know, and particularly because we're in a situation where all of our data is unique. We do not have. There's not like another copy of this 560 terabyte file server off someplace else, because if the researchers had that money, they'd rather spend it on GPUs.
Yeah, almost every university research department I've encountered, their ZFS pool is the only copy of that data.
Well, I think some of this also comes back to what Michael said a little bit ago, that a lot of us have different use cases, and so there's going to need to be different solutions that we all implement.
I think to Alexander's point, a lot of people want ZFS to try as hard as it can to keep working and stay up, whereas some people are like, I'm very happy for the pool to stop working as soon as there's any danger. And I think
at what point is that ZFS's problem? I mean,
yeah.
We were talking about administrative level things. Is that really part of it?
No, I'd first like to mention that recently there was a patch, I think from dRAID or somebody, to handle case of massive failures, to idea to not degrade multiple disks same time. The closer we get, potential. I haven't looked exactly on the code.
Well, I think one of them was, normally we fault up to your level of parity disks, but if one or more VDEVs is a replacing VDEV, we don't consider that one a healthy one, so that we won't fault even more disks than we really have.
Yeah, so just in case we have some SAS fabric problem, we should not fail all the disks and get to zero redundancy. By handling that, we should not get to a situation when we're writing data without redundancy.
Yeah.
It would already help from some kind. From another, I'd like to mention that if you have RAIDZ 3 VDEV, then first failing disk is likely a problem of IT, and IT should already be notified and do something about it. Second failing disk may be questionable. Third failing, that definitely you're close to data loss. Next step would be, and then maybe in some situation you could block RAIDZ, but again, if there's any application, maybe in that case you should turn instead of freezing pool, you should instead make your NFS share read-only or do something to a service level, higher level, so that administrators still have fully functional pool, but something else should be blocked closer to the user and more with more reasonable error reporting, and something like that.
And maybe part of that is a new Z event for something like that. Like right now we have the state changes for VDEVs and so on, but you kind of have to be reading the whole stream and following the story to realize that you're down to a certain level of parity. Or maybe we just need a Z event that tells you every time the level of available parity changes, and when it gets down to 1, then a Zlet can do something about it. That might be, like you said, tell the application to do something. Instead of, assuming you're going to have the whole context, we can just say, as soon as we see this message, do this thing, instead of just, on every VDEV state change, try to figure out if you have enough parity left or not. And that leads to another idea I have that hopefully I can do sometime next year, which is unifying ZFSD and Z with a new netlink-based notification system. So we get rid of the, Z's problem of when it can't keep up with the events, it just keeps doubling the buffer size until it gets to 2 gigabytes of events, or 2 billion events. The customer was like, why is our memory leaking when the ARC isn't changing? And it's, when Z couldn't keep up with the number of checksum errors, it would keep doubling. It actually changes the kernel tunable and doubles it every time until it hit the maximum of 2 billion.
With no cap.
No cap. Delphix added a cap that you can specify in the Z config, but it's not a default. I don't think Z should actually ever be changing the kernel tunable for the maximum number of events. If it can't keep up, it should yell at somebody and maybe suggest that you increase the cap, but it shouldn't just double the cap without asking. Yeah, well, it could take all the RAM and OOM everything and just to deal with, you know, the fact that you're having a storm of checksum errors because your SAS fabric has gone haywire or whatever. Or you're just trying to read the same broken file over and over and over again until your checksum counters are in the millions. Say again?
Is there any way to rate limit that event generation? I mean, are we generating the same event over and over and over and over?
So Rod asked if there's any way to rate limit the event generation. I think certain events, like checksums, there is a tunable to limit them to like 100 a second or some number per second. But I don't remember if that's on the side that feeds into Z or if it's Z that applies the limit and just doesn't percolate them out more. But I think it also only applies to the one type of message that the Lawrence Livermore was running into that one time. I don't think it was done like holistically for all events or like per event type or something.
No, honestly, I don't know much about Z internals, but
Yeah, me neither.
I guess it should handle situation of it's been restarted or crashing or whatever. I just wonder if we reach it to some million of unprocessed events, maybe we should drop them and consider clean start and let's see, okay, where are we now? We don't care.
Yes.
We've been a week ago.
Yeah, don't try to read back everything.
Just drop everything, start clean, and try to resolve what we have now.
Yeah, that seems like a much better behavior than just keep doubling the buffer until we can't anymore. Yeah, because I think the customer ended up with over 100 million Z events in memory, and you know, only because they had enough RAM does that possible. But they're like, all our RAM is disappearing. What's happening? And we were searching desperately for a memory leak, and then eventually realized they're all really, really tiny allocations because the Z events, each item in the NV list is its own separate allocation because they're all strings, right? So it's a whole bunch of these. It was all from like the 64-byte kernel malloc buffer or arena, and it was, wow, that's a lot of 64-byte allocations for, you know, the VDEV name and the zpool name and all the little strings that are in each Z event.
We've each touched on different, do some quick story time. We've each touched on different little surprises.
Does it have to be a new story? So this is a story I've told a few times before. So when I was younger and maybe a bit less jaded, I managed to get myself in the position of being the NFS guy. And you know, the way I did this was that we had received a donation from one of our research sponsors of a fairly nice, for the time, machine. This was like 2010. And you know, it was, you know, a fairly beefy machine, and it had 4 24-drive JBODs attached to it. And I said, hey, you know, I could save us a lot of money by, you know, using this to provide our NFS rather than, you know, giving $1 million to NetApp or whatever. And so we did that. And it turned out that the drives that they had populated this thing with when they gave it to us were a specific model, which unfortunately I still remember. It's a Toshiba MK2001 TRKB, which had a firmware issue in it such that when the drive went into power save mode, it misprogrammed the voltage regulator such that when it came back from power save mode, it physically damaged the head. We did not know about this at the time. We did not know about this until I had an array of 88 of these that were all taking 100 milliseconds to respond to every read, because each read was getting 50 or 60 retries before it managed to successfully get that block. And this is where, like, you know, if, 12 years ago we had this, ability to detect slow drives, that would have made a huge difference in being able to diagnose, like, why is everything molasses?
It might not have helped because that one relies on detecting an outlier, whereas all the drives are that slow, then it assumes situation normal.
And one of the things that I've been sort of, looking for all the time since then is like any decent way of monitoring drive latency in one of these, big systems that doesn't basically just do the statistically invalid thing and say, oh, well, here's your 5-minute average. And it's like, I know why that's invalid. I don't have any tools that are actually any good for showing me that. Unfortunately, we're still sort of stuck on Munin for monitoring, which doesn't know how to do anything else. But that was sort of my sort of introduction to like drives lie all the time. I forgot to mention also that these were multipathed, and so in FreeBSD, G multipath sometimes hides errors from ZFS.
A little bit, yeah. Like when
Because it
it
will
fails, it switches to the other path, and then when that fails, it switches back to the first path, and it doesn't always tend
I
to
mean,
percolate
it,
things.
it does eventually give up, but that means that if you thought you were only getting 100 retries, you're actually getting like 200 or 400 retries. So anyway, that's my story.
Yeah, I had a kind of similar one where we had this one model of Western Digital, I think 6 terabyte drives, and eventually the smart test found problems in all of them. In the way we had partitioned the drives, we had like a 6 gig swap partition before the ZFS partition. And at right kind of near where the ZFS Uberblock ring is, at the from the labels at the beginning and the end of the drive, in the space we had never written to for the 4 years we had the drives, all those sectors became unreadable, even though like where the Uberblock ring was working fine. We read and wrote that all the time. But this kind of unused space that we had near there, all those sectors became unreadable. And the drive would be like, yeah, those are toast now. And it's like, what did you do to those sectors that we just never wrote to? And it kind of shows why it's important to have something like a scrub that's going and reading sectors. In this case, it never touched those because it was outside of the ZFS partition. But reading those and noticing they're degrading, and the drive might rewrite them while it still can read them. Whereas if you have sectors you just never touch, they can bit rot.
Yeah, one of the policies that I've actually had for a long time is that basically the first time it throws any kind of medium error, the drive is toast.
Yeah.
Immediately comes out of the array and gets replaced, hopefully. And well, usually I'll do at least a smart long test which will confirm that in fact the drive is toast, but at least it gives me something that I can like give to the vendor and say, hey, give me your warranty replacement, please.
Of course, Western Digital didn't make that drive anymore, so they gave me a replacement that was SATA instead of SAS.
Oops. Oh, I would have been with that.
Were we at break time, or?
Go ahead, Alan.
You had a slide that said break time. Is it break
Yeah,
time?
we are at 2 minutes to break, and I have zero problem stopping 1 minute and 30-something seconds to break. Any other last points, questions, ideas? Well, thank you, everyone. We'll break for about 10 to 15 minutes, and up next will be Stu talking about dRAID versus RAIDZ. Thank you.
That sounds like feedback.
That does sound like
It's got to be the beard. Yeah, that's way loud.
Okay.
There we go. That sounds better. All right, ready, set. All right. Hi guys, I am Stu Redfield. I am currently the Vice President of Cloud, Infrastructure, and Architecture for Digital Glue. One of the things that brought us here, as well as helping sponsor it, is our Creative Space platform, which obviously lives on ZFS, and love it, love it, love it. So, in all of that, we've had the opportunity to actually test dRAID alongside zRAID. And as I've been stepping through it, there are some idiosyncrasies that hopefully we're trying to figure out. So I'm not going to go through the whole dRAID presentation from last summit because I don't remember it all. But it's in the slides. So, and thankfully to Michael who put all this stuff in here to start it all off. But the concept of dRAID versus RAIDZ or traditional RAIDZ type of environments. And we have the opportunity to actually start really testing it to see if it is as performant, which for most parts it is, but it also has a few idiosyncrasies that we're trying to sort out, whether it's, you know, a Linux level thing, whether it's a ZFS thing, or whether it's, hey, just how we are evaluating how dRAID works is a little bit different. So I'm going to drop right into the testing stuff, and hopefully we'll be able to have, and not have the, hey, we're going to demo something live and everything breaks. So it worked 3 times this morning. It worked about a dozen times last night. So we'll play it by ear. All right, so Supermicro chassis, 4 JBODs split across 2 HBAs, or JBOD access. I've got a Western Digital Data 102, Data Store 102. Obviously 102 drives in it. The one we're going to be testing with has 17 18 terabyte drives, 78 18 terabyte drives in it. CPU specs, memory specs. It's Ubuntu 2204 on the 6.8 kernel. And I've tried it with both 225 and 226 for the OpenZFS versions. Anybody wants to read the quick details? This is the setup that's consistent across everything for this test. Anyway, so the first scenario, which is the one we'll actually replicate in the conference, is 72 data drives in a 6x12 setup. And similarly, the dRAID, which I think is set up exactly the same way based upon the configuration set. And then the scenario 2 is one of our production level ones that are running this as well. So, simple create for the dRAID on top, level 2, with 12 spares against 102 full devices. And because this is multi-pathed in, obviously we're running the mapper devices. Similarly, the normal ZRAID piece, same thing, just in 6 drive chunks. So in my mind, and according to all the documentation I have been able to digest, that's where we live. So in addition to some of the standard IO zone and FIO testing, there's a tool called SPIT. It's written by a guy who used to work for a company that's now defunct called Myriad. He spells his name Stu wrong, but other than that, it's a great guy. it really exercises drives, and it has a lot of statistics in it, and I'm not going to go through everything with you guys on this because each cycle can take up to 15 to 20 minutes. So, but I do have some of the reference information there. Obviously FIO as well. So these are the exact tests I ran, and the exact tests will run for some of this stuff in a little bit. So before we go into actually doing a live one, this is actually, I ran this last night, and the spit whole run ran 111 seconds. The exact same configuration in dRAID mode took 227. So there's something amiss in there. Why, how, doesn't really matter yet. The FIO test, again, similar things. 58 seconds versus 3 minutes 23. And you notice almost all of that is in the real-time space of it. User and system are both pretty similar, at least for all the random testing. So one of the things that I was doing during this is while it's running, I'm running zpool iostat against it. And you can see on the RAIDZ, that 59 second, you'll see in the 2.5 to 6 gig range of traffic. On the dRAID, it's presenting back less than a quarter of that. Whether that is how the iostat is recognizing the dRAID performance or throughput or anything else, don't know. That's why I'm presenting it, but it seemed anomalous and it's pretty consistent. But if you add up all the math, they all spin the same amount of data all the way through. So, in reality, this is against that 78 drive one. So, it's going to build the RAIDZ. Building. It's going to tell me to start the iostat once it's done. Okay. Start that. And now this is running that FIO test that was on the previous slide. And this will take about a minute. And you'll see over here, if I punch that up a little bit, you'll get that 6 and 7 gig every couple second pops. Great TV. I understand watching log files is kind of our business, but all right, so 25 seconds left. And I'm using FIO just because it's shorter, and for the presentation, I can run this all day if anybody wants to see it in the background throughout the conference. All right, so that one's done. Took 57.8 seconds. That's going to go rebuild it as dRAID. Hey, typing error. It's all about creating things.
What is the file throughput numbers on the
So the question was, where are the FIO numbers? Yeah. On the right, that's the throughput that FIO is saying, or sorry, iostat. Oh, I'm sorry. Pop that up.
So 2 gigs a second of read?
2 gigs read, yep, and 720 write. And that's it's in the presentation too, from an earlier test.
So for those reads, do you see them showing up on the IO stat a lot, or is it mostly from cache?
Mostly from cache. In the spit testing, you actually see the read bandwidth fluctuate through because I run it at a much higher level, so it's actually breaking over the memory. But that can take 15 minutes a cycle, and that's really boring TV. So. So yeah, that one hasn't finished the thing. So that's about 3 minutes. So that's the reality of what I'm testing, if it's valid or not. Alan, go for it.
So what I'm seeing there mostly when you're doing the file writing is you see ZFS aggregating the writes in memory and flushing them out every couple of seconds, and you see some seconds there are
Big
0,
specs,
even though we're doing all these async writes.
Yep.
And so that's what I expect. Part of that is also that ZFS is probably aggregating those into bigger writes, and that's working nicely. With dRAID, every write is always full stripe, unlike in RAIDZ.
Right.
And I think that might be why, like when we're doing the dRAID one, we see the writes are
consistent.
slower, but it's happening all the time because there's always a transaction group flushing. We're never getting to the point where we've kept up enough that we can take a break. And I'm wondering if that's just because of the fact that dRAID is always a full stripe write, whereas RAIDZ will write a partial stripe.
Right, and that's part of the reason for this was trying to figure out if we're looking at things side by side as a comparison, is this a valid test?
Yeah.
And as we go through further testing and designing what a full test suite looks like in the real world, where does that performance match? So we can say A is B in this scenario. And that's one of the things we want to get out of this.
What's your workload look like? So dRAID was designed with larger blocks in mind, like not 128K, but really 16 meg, but even maybe 1 meg, you might see less of a drastic difference with a larger record size.
Yeah, on the spit output, we actually go up to really large blocks. So it's most of the stuff that my customer base uses is all video. So 8K level video, so it is big chunks.
Right, so are you changing the record size property on the ZFS data set that you're testing with?
No, these are consistent with the exact same.
The default 128K?
Default 128, yep.
So it might be interesting to compare RAIDZ and dRAID with the record size set to 1 megabyte.
Sure.
And also, if you set primary cache to metadata, it will not give this weird effect where your read performance is faster than the drives are actually doing.
Right.
Because it will just only cache the indirect blocks and not the data. And that way the read results you get will actually reflect what an uncached read will look like.
Right. No, and these are the type of things that as the user side of this is we don't know all those pieces. And with the number of variables that are out there inside of ZFS to be able to say, hey, tweak this, tweak that, where's the right starting point saying, this is a normal RAIDZ configuration. Okay, to go to dRAID and get equivalent or better performance, hopefully better performance, start here.
Yeah.
Whatever that translator is, or happy to help write that, test it, whatever. But those are the type of things that is why we want to have this, because we've discussed it on the call multiple times, and it's.
But yeah, I think one of the advantages of dRAID is because each disk is distributed, that you would likely use less redundancy. So you'd make your RAID groups slightly wider, knowing that you're not going to have the same penalty for resilver.
Right. So
you would get more data in the same number of drives. The trade-off is you have to use bigger chunks to really get the performance out of it. And if you do have any small blocks, like if you do have a 16 kilobyte file that's like metadata about the video or something, that's going to take a whole stripe and waste a lot of space.
And that's the balance we're trying to figure out as well. Because I mean, that's obviously in video processing, having that metadata or even silly spreadsheets around.
Yeah, spreadsheets or a text file that has the description of the movie or whatever.
Yeah, and anything that is, again, we don't do anything in compressed in ZFS at all. Zero, none. It does us absolutely no good. So that's the first thing, compression is off. on everything that
Yep.
we do.
Do you have
Nine-
a
95%.
lot of files though?
Yeah.
So some other media and entertainment companies we work with, in their workflow, like they have 8K video, but every frame is a separate like 80 megabyte file.
Right.
And so they have a huge number of files. But it means that when you go to a larger record size, like if you use a 16 megabyte record size, then if you have a file that's not a multiple of 16 megabytes, that last chunk of it will take 16 megabytes even if it's
Regardless.
not. And
Yeah.
turning on compression on these uncompressible files is expensive.
Yep.
So we have a prototype for something called slack compression that basically applies zero elimination only to that last block. And
Okay.
makes that one take 4 megabytes instead of 16 if the file happens to round out that way.
Right. Yeah, the
and
red,
that
the
would
red
be
cameras are the notorious ones for that.
Yeah.
They generate a ton of stuff. And
Yeah.
So,
And where you wouldn't have to pay the cost of compression, but would be able to get the space savings. But if you're using dRAID, it doesn't make sense because you're going to write the full stripe whether the file's 4 megabytes or 16 megabytes anyway.
right. So, pardon?
And those are really big files.
Mhm.
They're dealing with computer vision researchers. The very first thing they do when they get, video is, well, they write out like, 1 frame per file, but they're only like, 100K.
Mhm.
So,
They're doing their own thumbnails on the fly, basically?
well, not really on the fly, it's that's what they're training their machine learning models
Oh,
on.
the file is imported, it does a frame grab
Yeah,
to do that. And that's normal too. I mean, so is building proxies off of original files. They're obviously much smaller. They're still representative of the video that's actually being acted upon.
As far as those little kind of metadata type files,
Hmm?
would that be a good use case for special meetups?
Potentially, it's. Sorry. Yep. Say it one more time, Andrew.
As far as the
Using a special dev to handle metadata.
handle as metadata files.
Right. And fortunately or unfortunately, we are restricted by how the software that is using the files wants to find the metadata. Some of them want sidecars, some of them want it, directly next to it. Some can look at other directories for metadata if they're not using some sort of advanced MAM that houses all of that metadata for them outside of the file itself. So the answer is yes, but no.
Like that's where the small blocks feature in ZFS for special VDEVs came from was, when we're using 16 megabyte blocks, if you do have any small files that are under a certain threshold that you configure per data set, it will store them on the special VDEV with the metadata, like the ZFS metadata, so that, you can use those, you can use mirrors there and not waste a whole 16 megabyte stripe on, a 4 kilobyte text file that describes what the video is.
Right.
Or who owns the video or whatever.
Yeah,
metadata.
all the magic.
Yes.
All the magic I don't have to worry about because somebody else, that's those Patrick people that like to do video. So yeah, you can go back. So it obviously finished minutes ago, but so it's still 2 gig, 700 meg.
So
roughly
how
same.
big was the difference between the FIO, the RAIDZ, and the dRAID on the actual writes?
It's basically the time delta between 321 and 57.
Right, but the actual
The real time.
megabytes per second on writes reported by FIO.
So the first one was 2149 read, 720 write.
Yeah, 720 write, and the second one
That
is,
2183 and 732.
yeah, so that's actually about the same speed.
Right.
Tony pointed out that it looks like most of the time delta is actually coming from FIO pre-allocating the file, not the actual writing. So there's a flag in FIO, I think it's -f allocate equals none.
Right.
And it will skip that step. Since you're just randomly writing to the file, we don't need to fill the file with junk first. And in this case, you're not really trying to test the reads because you're only ever reading
Right.
what we just wrote.
But and the reason for that, and I've tried it as well, it is for consistency.
Right.
Because one, trying to figure out why it's inconsistent,
Right.
and what that
So
performance is. So
if,
that was,
if you want to look at, if we look at just random writes to the files that were empty to begin with, I think from these results, it looks like you would actually get the same write performance for RAIDZ and dRAID, even though in this test you're seeing wildly different performance.
Right.
Because the once we get rid of the allocating part of it, then we see quite
Right.
different results.
yeah, and again, the FIO stuff was to be representative here.
Mhm.
After this, we can go through the spit results,
Mhm.
and I'll provide those in the slide as well. But there are things in there, and it might be how how the testing tool is, corrupting our view of it, which goes back to what's the right testing tool for us.
Well,
And
FIO
configuration
can be
of-
the right testing tool. Even in this test, I think if you don't do any other orchestration and just run the dRAID test a second time with the files already existing, then I think you'll see a very different result. Right? 'Cause
Yes,
you're
that is
like
true.
destroying and recreating the data
Yeah.
set. So now that the files are pre-allocated, if you just run the dRAID again, does it take about the same amount of time as the RAIDZ?
Yes, based on previous tests.
So that makes a very interesting question of what is different about the pre-allocating workload in FIO. And I think the difference is pre-allocation in FIO is single-threaded, whereas you're running a num jobs on the actual writing.
Yeah, the actual,
Yeah, the actual benchmark uses multiple threads and is able to get the same performance as RAIDZ. But when single-threaded writing, dRAID is being much worse.
yeah, so that's the FIO test. Where's this
Where's
script?
the job number?
I didn't, sorry, I
Yep.
didn't paste that in properly, apparently. I just ran the run portion of it, but
Mhm.
I will add that back into the
Yep.
template, so. All that being said, and Alan, thank you. I mean, this is why we're here.
Yep.
And part of it's my ignorance, and I'm happy to learn. But trying to figure out, for newbies, anybody we bring into it, it's like, okay, what should I run? Do I run ZRAID, or do I run RAIDZ, or do I run dRAID? Obviously, there's a number of device limit that you don't want to go below for dRAID. Whatever that number is. Alan? There's,
Not enough practical experience. That's why I'm very interested in
Right.
what you're doing here.
we can
but I would
we can
imagine-
break this. I've got a week left before this has to roll into production,
Mhm.
so we can
Yep.
beat it all up, basically through next week.
But yeah, I imagine it's somewhere like 24 to 36, where less than that, you probably just want to stick to RAIDZ.
Right. And that's kind of where my line in the sand was until this conference.
But I think the big thing is, if you have a lot of small blocks, then dRAID is a non-starter, because it's going to
But do the
use up all your
lines right.
space and have these giant stripes that are full of nothing.
Right. So actually, we answered most of the first one. So happy to finish the any other conversations you guys have or questions about it. But just wanted to leave you with my original thoughts on this. So the first big bullet we've already covered, and Alan's pretty much put to bed. Configuration and tuning recommendations and warnings if the feature dRAID is active versus enabled, just to say, hey, you might want to consider this as we move forward. So whether it's something in the ARC that is better, needs to be better tuned for a dRAID environment.
I don't think there's anything I'm aware of that you want to do differently with dRAID, other than realizing that every write's going to be the full stripe, and that's going to change
Based upon size.
the shapes of a couple things. But
And
In case of
Uh,
login, you mean
Patrick.
ZIL writing, like synchronous writes, then probably dRAID is the worst possible scenario for ZIL, since it has to flush all the disks in a pool practically for each commit, for each transaction. So in that case, you would definitely like slog if you need synchronous writes,
right.
more than any time else. And
yeah, so if you're doing
and-
NFS with Linux clients, you definitely want to slog.
yeah.
So, and again, finding that right balance of, hey, I've got 204 drives out here, what should it look like? Any guidance on that, then we can then go and tune in and saying, you know what, it's actually better at 80% of that or 140% of that.
Yeah, I
and
think
use that
in
testing.
your case with the larger files, probably wider VDEVs will give you more space and probably more performance. Like with the 6 wide, it's in a Z2, that's pretty
No, 6 wide Z2 is too aggressive, but dRAID in such configuration probably doesn't make much sense, because in case of dRAID, unlike of RAIDZ with multiple VDEVs, in case of the dRAID, if you lose 3 drives out of 103 same time, you lose your pool.
Right.
So in that, if you use dRAID and you won't use it where it should probably be, it should be much wider RAIDZ groups, parity groups or whatever we call them there, so that you would get maximum space efficiency, maximum throughput, and still you understand that losing of 3 disks is critical, but for that downside, you actually get benefits of much better space efficiency and so on.
Right.
And with RAIDZ, you can indeed afford smaller sinks, 15 smaller VDEVs, and you can lose 3 out of each,
Right.
not 3 total of them. And in that case, you can store much smaller blocks.
Right. And part of this too was trying to maintain here's a consistent reality of, you know, how we deploy it on a 24-base system is, you know, 4x6. It's done. I mean, that's the most efficient way through our testing and our customer base, that's how it works the best. So again, finding the right way to test it and, okay, here are the right configurations. That's what we're looking to come out with. Which brings me to...
Just before you move on,
sure.
for L2 ARC, I think with 192 gigs of RAM, you're better off putting in more RAM than an L2 ARC.
Right.
For such big ARC, you would probably need quite a lot of L2 ARC, and for that, several times recently, I'm trying to motivate somebody to actually work how L2 ARC is written. We're not very efficient on the speed of writing it.
Right.
So by the time it will get full, your system will be 6 months in production.
Right.
So, so maybe maybe in addition to L2 ARC, or instead, as Alan told, more RAM plus special VDEV if you need to store small files or a lot of metadata, just access metadata fast from special VDEV and do streaming from everything else.
Right.
If you have a very large file, what chance that they will land on L2 ARC, and will actually L2 ARC be able to provide you as
anything
high
useful, right?
be useful? And it's quite often, if you have so many drives, if you have very good host connection, they could be much faster than any single SSD you put as L2 ARC.
Yes.
Even if it's NVMe.
I've broken that. Yes.
So,
So
Yeah.
and to your point, Alan, and there are, you know, we're actually deploying a system next week that has a terabyte of memory in it, doing a very similar thing. So that's obviously, this is again what we've got to test with, and here's how we're playing with it.
Like very much to Alexander's point, in addition to the default tuning for the right throttling on the L2 ARC is from the year 2005. The other problem is that L2 ARC is kind of a misnomer in that the cache device doesn't actually implement the ARC algorithm. It is just an LRU. And that's not very efficient most of the time.
there are actually a number of problems if somebody interested in quick summary. So the first, when we in ARC introduced multi-list structure to make ARC more SMP ready, L2 ARC kind of suffered from it because it writes only from one sublist each time at a time. If we have a lot of CPU cores, it means once per second we can handle only 1/64th of ARC. And then again and again, and it may, at the end, we are not writing to L2 ARC everything we could, because we just getting no data at the time. We should instead scan all the list, but equally and progressively. There are some tunings that could overcome that, some headroom, but then it will cost CPU at the end. Okay, once we get to some throughput, we should put more attention of what actually we are writing, Because right now there are options, we can write only metadata, we can write data, but again, balance is not particularly great. Also, it tries to place something about prefetch, like not write into ALC prefetched data. But I think logic should be slightly different. What a chance, like we should probably not write into L2ARC data that were actually read into ARC before the hit. Because if main storage can do it fast enough, don't write it to L2ARC.
Yeah.
Leave it to main storage, that's good enough. But if access is random, main storage can't keep up, then write it. That's another thing we should rewrite into L2ARC.
Yeah.
So there are a number of ideas I have floating around that should be done by somebody.
Yep, and all throughout the L2ARC code, there's XXX fix this in L2ARC 2.0.
Yeah. No, it's actually, I see it as 3 or 4 smaller projects. It doesn't need to be 2.0.
Yeah.
It's quite incremental
maybe
process.
we should
I don't actually
get those written down.
What was the original point of 2.0? Was there some dramatic?
I don't. It's so long ago. I don't think anybody remembers.
But
those lines are from early Illumos.
But to that point, is it something that will be as it's being developed, it'll be configurably, tunable by workloads?
But I think
my workload's not the only one I care about.
Would just never benefit from the L2ARC.
Right. So, if that's the case, we're at a point in the
Use
hardware.
those SSDs for special videos.
Yeah, in their hardware level, hey, we don't need the complexity. Great. I'm all about reducing complexity. So, whenever we can. Any other questions, concerns, comments?
Yeah,
So-
looking at your next. Oh, sorry.
Oh.
Go ahead.
Number 4?
4.
Okay, so one of the things, and we sort of ran into this issue starting probably about 8 years ago or so, where we're really just not finding any benchmarks that look anything at all like what our user workloads look like. We went out, we licensed the spec SFS 2014 benchmark, and we did a bunch of work with that. But it's like, well, here's these canned workloads, and none of them say like machine learning or computer vision on them. And I have a better idea now of like what a computer vision workload looks like. It looks like, loading 100 million 128K files in random order. And, I'm wondering if folks have any better ideas at all about, what's a reasonable modern benchmark.
I don't know that there are many. One idea we've thought about is basically making a recorder that would sit on ZFS and record not the data, but the shapes of the blocks and the patterns that we could just replay filled out with random data in the future to basically turn a recording of any workload into a benchmark that could be repeatable. Because short of that, I don't know any benchmark tool where you could try to explain a workload and have it make something reasonable.
Yes, please. Please, please.
Yes. So repeating the comment, what's your name?
I was just saying.
Your name?
Andrew.
Oh, Andrew.
Andrew from the back mentions that no benchmark is going to match your real-world workload. So being able to record 5 minutes of your real-world workload and be able to repeat that in your lab environment and tune it until it works how you want is the only way to actually have a real benchmark of your workload. A lot of times with FIO, we're just trying to recreate the worst-case workload and make it good enough and hope it'll work. But being able to, especially if you want to tune something like the cache, like if you're trying to decide how to get the most caching efficiency, having a workload that's more realistic than either just all random data that we're accessing completely randomly or whatever, or if you want to benchmark prefetch, it'd be much easier to do that repeatedly if you have a sample of a bunch of different workloads or whatever, different kinds of workloads, and being able to tell objectively this way of doing prefetch is better for all these workloads or 80% of these workloads, rather than it worked well for the tests that I could think of.
Yeah, I think, having something like that, in particular that we could publish and say to file system developers or vendors or whomever, hey, this is what our workload looks like, please tell us what to do, or please make your system perform better on this workload.
Yeah, and kind of to the bullet point here, on FreeBSD we have Olivier Couchard-Lebay maintains a repo called NetBenches, where he has a bunch of firewall benchmarks that he does, and there's a subdirectory for each different hardware platform he's tried it on, and then it shows like the different versions of FreeBSD he tried it on. And so you can actually see the performance of this same workload across revisions of FreeBSD, and a commit that made the firewall 20% better and so on. And I'd really like to have a bunch of these workloads and these kind of graphs with ZFS is saying, yeah, when Mav made that commit, everybody's workload got 10% better. This is great. Or, hey, we saw with this commit, there was a regression on this specific workload. Can we, make it not as bad? And while at the same time not having to just give up the benefits that every other workload did get from that commit, and being able to track, performance over time just to tell when we've made changes or when things have gotten crazy. Yeah, so Rod's comment was, again, back to what we were just talking about. You almost need something where you could capture packet flows and be able to replay them. And yeah, like something that on the storage level.
Yeah.
Something, one idea could be like BPF trace, where you can just trace all the IOs.
Yeah, so something like BPF trace or dtrace, or I think there's block trace or something on Linux, where you can kind of get these kind of heat maps of where on the drive things are being written and so on, and being able to try to recreate similar patterns in a reproducible way.
About version comparison, we are doing that part of TrueNAS development.
Mm-hmm.
We have a team of 3 people doing just benchmarking 24/7, not but at least 5 days a week.
Yeah.
But the system running 24/7 actually non-stop in order to handle like each release in each 6 months, full qualification of half dozen different system in half dozen different benchmarks, with ability to say, okay, here we got some slightly better, why? Here got worse again, why? Can we do something about that point?
Yeah,
so we are doing that, but that's quite an effort. It's definitely not something that can be run automatically without human presence.
Yeah,
It's,
and how can we make it, so that somebody could do this by themselves without needing a whole team as well. And yeah, the answer is it's complicated, especially when you get to the asking why part.
Like the data collection side of it and saying, hey, workload, here's my workload, here's how things are working for me in this environment. Being able to collect and consolidate that information in a single community-ish fashion is something that I personally think would be fantastic if we could get behind it.
Yeah.
Yes, sir.
So what was the motivation of doing this test for ZRAID versus dRAID? Like, is it something specific?
The motivation
Repeat
for,
the question for the stream.
So the question was, what's the motivation for defining whether to do dRAID or go against RAIDZ? One, I've got some big arrays, and they're really challenging to do maintenance on. And if I've got dynamic spares that are built in, that changes my operational costs. If the performance is within an acceptable point of how things operate now on RAIDZ, and they work on dRAID just as well, or in that realm, do it all day. It simplifies my life and my team's life of, hey, I only have to go on site physically, twice a year versus every 2 weeks or every, depending on what the drive cycle is, which varies on device type.
So yeah, the big caveat I will put there is, as Mav mentioned with dRAID, if you make it a dRAID 2, if you lose 2 drives, you have no redundancy left. Out of like 2 out of the whole 78 or 102.
Right.
Whereas with RAIDZ, you're going to, as long as the 2 you lose aren't both in the same VDEV, you won't have to necessarily do a site visit yet.
Right.
And so really the advantage to dRAID is going to be make them wider without the resilver time going to the moon. And like you said, the dynamic spares mean that, when one does fail, you can hopefully replace it quickly enough. But in order to get the level of redundancy you need, you might need to go
It
with
gets,
like a
it gets
dRAID
much
3.
wider. Yeah.
Yeah, a wider VDEV, but also a dRAID 3 so that you can get closer to how likely a failure is.
Right.
That you're getting with RAIDZ, where, you know, while you have, the RAIDZ is going to end up with the same amount of parity, but that parity being more useful because it's separate VDEVs
Right.
than with dRAID.
Yep. And again, this goes back to what this demo was just for a apples to apples comparison.
Yeah.
Reality is what reality is, and that's where we take that guidance and go. So I could test it the other way with that 18, is it 16 or 18 drive limit on the VDEV right now?
Right now you're doing 15 VDEVs of 6 each, and we're just making it wider.
Yeah. No, but
whatever number works out to the right.
There was a
issue
hard
works out.
limit in dRAID, or in RAIDZ on number of devices per VDEV, wasn't there?
I don't think there's a hard limit. I think. Yeah, it's
Oh,
255 or something.
I-
But don't
I-
go that wide, please.
I thought it was 16. I thought it was 16 or 18 on something I read. I haven't tested it.
I probably wouldn't suggest going over 16 or 18, just because the resilver time would
Right.
possibly be immense. But nothing in ZFS stops you from doing something silly, because that would also stop you doing something clever.
Right. So
The Unix.
excellent. So that's all I've got. You guys have any other conversations? Wide open. Otherwise, I have no idea what the clock is. Right on time. Who knew?
Still 20 minutes to lunch, so we can socialize, take a break, whatever.
Excellent.
For companies that already have storage systems that are already set up based on ext2 or ext3, I was trying to figure out how to package and encourage them towards the OpenZFS direction. How would you approach like trying to help explain to people this is really a new direction?
Honestly, I think it's a great question, but I think the best time to do
Repeat
that
the
is this
question.
afternoon.
Yeah, okay, fair enough.
Because we have a session just around that, and tuning that up into, or serving that up to, hey, this is how we sell OpenZFS philosophically and financially, depending on, or as a service. So I think that's a better time for it, but great question.
I have a lot of examples in my head right now, solutions I worked last week, and I'm just like,
How can we make your life better? Yes.
oh, sorry. Okay, anyway, I'm done talking now.
Patrick doesn't move as fast as he does.
Yes. But yeah, I think kind of to that point, the biggest thing is I don't think anybody's in love with their hardware RAID controller.
No.
Especially if they've ever had one fail and tried to replace it. Or
That's that's 8 years old.
The
Yeah.
issue that I saw a customer have lately is, they had their separate HPA, but somehow the RAID one took over when they reseeded some stuff, and it decided that there should be an invalid MBR partition written to every disk. And then their
Ouch.
pool wouldn't import anymore because the label was clobbered. And we had to recreate the right partitions, and ZFS could find the pool again, but it was the evil things that hardware RAID controllers do is usually enough to convince people, especially if they ever have any pool that's, more than 8 drives. Then as soon as you're looking at something like that, it's like, I want a lot more control over what's happening here and visibility on what's happening as well.
And it's not all about vendor Kool-Aid.
I think sort of related to that is that, we've seen in recent years, like certainly in like the years that I've been doing this, we have a lot more extra CPU sitting around on these servers now that can be put to better use. We don't need to hardware offload everything because, it's a 64-core server. It can just do it,
Yeah, the ones we were working with recently were AMD systems with 512 threads.
Excellent.
I can tell you, we have a hard policy of if it doesn't go into HBA mode, no.
Oh, yeah. So Andy was saying, you know, at his place of work, they have a policy that if the card can't be dumbed down to an HBA, then they don't use it. And that's a good policy.
Absolutely. Excellent. Thank you all. Now that was
Okay, we live? Thank you, sir. Let's continue, and thank you everyone for a great morning and a great lunch. Thank you, kitchen crew. Up next, mixed operating system environments with OpenZFS. It is a very cross-platform file system, perhaps maybe equaling or slightly beating on many fronts FAT32. So the good news is OpenZFS supports Illumos through cherry-picked features, FreeBSD, GNU Linux, macOS, Windows, NetBSD, and Solaris. Your mileage may vary on Solaris. But the bad news is it supports all of those, which makes a few challenges a thing we got to deal with all the time. And we could lead with story time, but let me just punch through some topics that have come up over the last few months. And in those challenges, above all, heaven forbid there be a pool creation time flag that you forgot that you might need, bless you, for your comfortable cross-platform support of your shares and pools for import.
What do you need to disable?
And which you need to disable. So Alan, be ready with your wisdom.
Which is, if you want a pool to be compatible with all of those operating
Does he have a
systems,
microphone up? Awesome.
Yep.
Let her rip.
if you have a pool you want to be compatible with all those operating systems, especially if Illumos doesn't have every single feature, then at creation time you might need to make sure not to use certain features. And so disabling just those feature flags when you create the pool. Luckily, newer OpenZFS has a thing where you say compatibility equals a macro so that it's easy to create a pool that's backwards compatible with whatever older version of ZFS or specific version of TrueNAS that you're trying to be compatible with.
Are there flags beyond feature flags like normalization and other things that you may need to
That's
set?
per data set.
Purely per data set.
I don't think there's any that are per data set that would be different across operating systems.
Got it. Thank you, Alan. And Patrick, I might be a bit hot. Go ahead.
Yeah, that's not exactly
One sec.
Let's pot him
Is
up.
3 born? 4.
Thank you.
There's not exactly feature flags, but some dataset features may be different between OSs. Different ACL types. ZFS supports NFS v4, but potentially some may prefer POSIX. Those store it differently on different platforms. And obviously you set one, you import a different platform, you just lost all ACLs. Done. There could be several properties which work slightly different. NFS export, SMB export, obviously.
The old vol mode.
Vol mode, yeah. Dataset level.
Those ones are data set.
The question was at pool level or data set level. Okay, so it sounds like we have the feature flags as a blanket accommodation, which is getting better than ever, and hopefully the FreeBSD installer, for example, will let you choose a pool level for feature flags. I've made a mock-up of it for the front end, but not yet the back end. I've got someone looking at that. Moving on, let's go through the points and we'll dive in with those real world, because between you and Mav and Alan, I know we've got some good answers there. We touched on the perennial challenge of sharing both NFS and SMB from the same data set, especially across different OSs. And mind you, a bunch of us are coming from the VeriSign perspective, where to preserve .com, they are dual stacked Linux and FreeBSD, just institutionally, so that if there is a catastrophic issue on one or the other, they are hopefully covered and going to continue. So some organizations lean way into that, and they want to be feature parity compatible, et cetera. And then I don't know to what degree NFS v4, v3, or SMB protocol levels might play in, but let's get to that later. Excuse me. And start thinking about your real world challenges. And is that actually as far as I went? Boom, yes. So that said, Alexander, can you talk about what Acrobatic's TrueNAS does to accommodate, be it the common NFS and SMB sharing? And I know you've got a Linux-based product and a FreeBSD-based product. Can you summarize just what, through your blood, sweat, and tears, you've come up with to address these issues?
I know we have some deployment of that kind, but I don't remember how big they are. Obviously, we need working ACLs compatible between them, and NFS used in both cases, they are more or less close. I think there may be some artifacts of some specific bits, but generally they should work. But as far as I know, biggest issue is lock-in and caching existing because they use different models on SMB and NFS, and that's work of different team. I'm not qualified to answer it fully, but that's a difficult topic. It's possible, it's doable, but at least as far as I know, I wouldn't use it for simultaneous access to same files. Like either read-only for both or different files at different time or something like that. Otherwise, it may create some pain.
Alan, have you deployed any mixed environments like that where it was a hard requirement to either have a very portable pool between OSs or multiple protocols shared off the same data set, which might
Not
lead
really,
issues?
no.
Okay.
No. I know recently the article we published on our website showed how to use ZFS boot menu on Linux to run multiple distros off one pool, but that's, generally hopefully the same version of ZFS on all those distros, but it doesn't have to be, again, with that compatibility equals flag when you create the pool. Beyond that, I think currently in the wild, most people's use case would be a one-time migration, and so just reconfiguring your NFS properties isn't the end of the world versus, what we talked about, I don't know, 2 years ago or something on the leadership meeting about can we standardize the settings in, share NFS equals in ZFS so that they do the right thing on the different platforms, or at least have, share NFS is just an alias to share NFS.FreeBSD and share NFS.Linux, where the pool could retain the right settings for both, but then how do you make sure the user updates both when they actually make a configuration change and you don't end up at, when they switch back to Linux, their NFS rules are 4 versions out of date, or 4 revisions behind what the rules on the other operating system they were running on. So that's a challenge. But luckily I've not had to deal with people trying to run NFS and SMB on the same files at the same time, because as Mav said, it's short of trying to get both of those to let ZFS handle the locking for them or something. There's not really a good way to do that.
Lock-in's one side, but NFS v4 and SMB both use user cache delegation, so that if one protocol delegated user to cache the data, other won't know it. So that's if file accessed by both, it's a request for corruption at the end. So it should not be simultaneously accessed for right by both. Or but you mentioned booting from different OSs. That's actually one trick we use it as I'm still using partially as a path for migration from TrueNAS core to scale. That it's possible to from the same pool actually boot both FreeBSD and Linux. And if I remember, biggest issue was there. While it's good for FreeBSD, that loader doesn't need any configuration. It just read everything. It can all data sets on a pool. It can boot anything. And pretty flexible. Linux require grub update, and after migration forward, and if once you boot back to FreeBSD, you cannot modify your grub configuration. That's maybe a challenge. But otherwise, dual booting like that from different boot environments actually works. That's
and like in general, I've seen like the way Ubuntu deploys it, they have the boot pool have like no feature flags enabled to try to avoid grub being incompatible with the next change they make in ZFS, and that's even been a problem in FreeBSD when we first import a new feature. Like I think when we added the VDEV Zap v2 concept, that the FreeBSD loader would be like, hey, I don't recognize that feature. How am I supposed to read this pool? And in general, maybe if a pool's only purpose is to boot from, keeping the feature flag list down to a minimum helps ensure compatibility and just that it doesn't change. But without the newer thing that the compatibility flag added, where it makes zpool status not constantly nag you to update the pool, it was less.
For that thing, actually, compatibility option is definitely a good thing. One pain we hit, so at some point we tried to update a config file for grub, And formally grub should have supported extensive data set, except we hit some bug in grub code that made it, I don't crash, or one way or another it doesn't boot at the end. So formally it should be read-only compatible and should not care, but grub doesn't support it. And we hit some grief trying to recover the situation. It's because once people already upgraded the pools, they cannot go back.
Yep.
And if we remove the options from the grub config, the pool will complain that pool has incompatible option.
Yep.
So I'm not sure how we will, how we should resolve situation like that in the future. Can we somehow prepare some mechanism to fix errors like that when we have to revoke some feature, but not call it a problem? But otherwise, a solution would be if you need dual booting, you should just compatibility set something like FreeBSD, grub, and then it should work. No, FreeBSD general loader at this point just able to boot anything, I think. We don't even have config for it.
Right, there's no config. It's just if you have, if you're trying to run 2.3 on FreeBSD 12, you would need, your loader would be like, I don't know what fast dedupe is. And it would complain.
But most of the features are read-only compatible, so it doesn't need to know what it is.
In the past it was bad about just being like, that feature's not in my list, so no, even when it was, it didn't consider read-only compatibility, or the fact that the feature's there, but it's marked disabled because it's never been used, or it's enabled but not active, like fast dedupe.
Well, I don't remember when it got support, but definitely right now we have enough functionality to handle disabled and unknown features which are read-only compatible.
I think Tumas did that, and we thank him very much for it.
Quick question there. Are there feature flags that are implicit in a send such that you couldn't do some acrobatics with a send to remove feature flags, if that makes sense?
No.
Insofar as you want to get back to, oops, I enabled a feature flag, I will do whatever it takes to get back to where I was. Can you do some acrobatics in sending to another pool and back to strip certain feature flags?
Yeah, so that was a point I made earlier. Right now, if you do ZFS send with no flags, it goes back to being compatible with V28, like, 15-year-old ZFS.
That's the question.
Which is helpful at times, but maybe not sane for a default today. Like, being compatible with ZFS 10 years ago is fine, but maybe we can, at this point, assume that everybody's compatible with LZ4.
I'd like to mention, most of LZ4 could be overridden just by not transferring compressed blocks.
Right.
But just
shouldn't compressed blocks be the default today?
Would be nice to, I agree. That's, we should extend compatibility options to cover or create separate ones.
Yes, and so the default is the oldest LTS we support of ZFS, not V28 from 20 years ago.
Yeah, but I'd like to mention one more feature was introduced recently in 2.3, long file names. And if you enable those and create actually long file names, question what would happen if you, you probably won't be able to send receive that to previous ZFS.
Yes, and we actually had a stealth one happen there with, we added the ability to have a large microzap. So by default, when you create a directory, if you have under 2,000 files in it and none of your file names are more than 48 bytes long, it'll store it as one big 128K block instead of a pointer map or pointer tree. And that works well. And so we added the ability to have a microzap that was bigger, up to the 16 megabytes. Didn't consider what would happen if you sent that to a pool that didn't, but by default, when you send, it doesn't send large blocks. If you have any records that are over 128K, it chops them up into 128K chunks, but you can't do that to a microzap. And so you ended up with only the first 2,000 files in the directory showing up on the destination. Yeah, so we had to make a feature flag and make ZFS send activate that feature if you use it that way.
So just from the user perspective here, could you add basically the same compatibility mechanism to ZFS send where you say, send me a stream that is compatible with this OS or whatever?
Yeah, exactly. That would be the idea. Would you do ZFS send -o compat equals FreeBSD 13.2 or TrueNAS 2304 or whatever, or ZFS 2.2, and it would enable all the features that are supported there and not anything else. And maybe we set the default to whatever the oldest supported version of ZFS is, instead of the current, which is default to being as backwards compatible as possible, and then all these different flags you have to enable to get bigger things. Because I think a lot of people would be surprised to find out that, you know, I was using 1 meg blocks, but when I ZFS send it to my backup, it's not using 1 meg blocks. And if I've already bootstrapped my thing, I can't switch to using large blocks after.
I guess it would be definitely good to have that thing. Just comes to mind that all the features has to be enabled. Like if you have on receiving side large block disabled and you try to receive that stream, even so it's formally supported, it's not enabled, it will fail. So user should be prepared to make sure that pool is upgraded to that level, or we should somehow.
Right, well, they're setting compat equals to that, so hopefully their pool compat on the receive side is set to the same level.
Does that fail gracefully, or does it say, like, hey, there is no large block support when you tried to send?
So before it would send and you would end up with a directory you couldn't read all the files out of. Now, when you try to send it, it says your pool has this feature enabled because you've created, as soon as you create a microzap that's bigger than 128K, it enables the feature, or it activates the feature. When you try to do a send without capital L, if that flag is on, it tells you, no, something in your pool wouldn't be compatible with this. You have to use capital L to replicate.
Since you're talking about compatibility aliases, I would think would be also useful to have a compatibility alias for just continue to be whatever I am. Because you said the default.
Like an alias for whatever version I'm running right now?
Yes.
Yeah.
Don't make me think, just follow.
Yeah. That can make sense.
Other stories, who's had sends and feature flags just bite them in the behind? Yes. And there's a mic in back if you like.
He has to turn it on now.
Now, on the compatibility thing, there's no easy way to learn what compatibility pool is created with. And that's something that might be nice if someone.
Yeah, that should just be a pool property. It isn't now, but yeah, we should save that as a pool property when you set compat equals. Yeah, so that later you can read back what compatibility level is this pool. We'd have to make it, when you zpool upgrade,
exactly.
it needs to update that property.
Yes, it does.
Right now, you basically have to use a equal property list and go back through it and try and figure out which compatibility that is so that you can create a new pool.
That matches, yeah.
I think we do have compatibility property because if you try to enable some option not enabled in that compatibility list, it will upgrade. It will start to will complain. We have some features
Okay.
that are not expected in that level.
Okay.
Remember the issue we had with the ZFS send, we had to use
That's the one I was just describing.
okay, got it.
That's why only the first 2,000 files in the directory would show up.
Yeah, exactly.
And so yeah, we created a flag, and that's fixed in 2.3.
It seems like possibly like adding that to the ZFS pool. It seems like possibly just adding that compatibility option as a flag to zpool status would probably be an easy way, because everybody uses that command all the time, and you just add a -c or whatever, and then you can see that. Just a thought.
When did compatibility aliases arrive? Is it something you can assume like LZ4 that everybody has, or there's still a lot of pools out there without some notion?
I think it's 2.2, so I think
Okay,
like
that's-
Ubuntu 2004 does not have that.
Got it.
And certainly older FreeBSD does not have that either, although I don't, are we still supporting?
Yep. So I
12
don't think
doesn't have that.
I think 12 wouldn't have it at all. 13 is 2.1, so I don't think has it either. So I think it'd be only 14 when you get 2.2 when you'd have that feature.
But do
It's
we
a
care
journey.
like if the features are supported themselves?
Yeah, like the features are, but like the actual zpool create-o compat equals, was that in 2.1 or only 2.2?
Probably to
Okay, 13 has it, so it is in 2.1.
And one angle on all of this is simply migration. Oh, we're tired of this OS and we're moving to this other one. Stu, in your environment, I assume you're one OS and you always have been. Do you ever need to go compatible?
Not as of yet, but with Ubuntu's lunacy and snaps, we're going to be migrating off of it.
So his response was, with Ubuntu's lunacy with snaps is motivating abandoning that platform. And that's probably as no fault of yours as a user. Thank you, vendors. From the back row, any experiences, questions, observations? Have we seen in practice people using the compatibility aliases, or is it just sort of an inside baseball kind of thing, or inside
I've seen
football?
a little bit.
whatever
I
play?
think your suggestion, like that installer should use it more, probably makes a lot of sense. Like, you know, when FreeBSD 14.3 comes out, it probably should still default to making pools that other versions of FreeBSD can use, or at least giving you the option to decide, you know, do I have anything older, or everything's going to be newer from now on?
Correct, and the one challenge there is that once you have the full list of options, it's like pages of levels, and it's like, well, yeah, no, I don't want to be back in, what, how many years back, 20 years ago, so
Right.
it's a fine line.
You know, the same things came up with just, you know, we were talking about maybe a VDEV property to manage certain settings. At what point does the number of properties get too big that, you know, it's multiple screenfuls and it's like,
It already is.
yeah, exactly. And so do we try to break those into groups and have like properties that are invisible by default, but with an extra flag will show up, so that, you know, when you do ZFS get on a data set, it's mostly the relevant ones?
I say
Templating it.
Yeah, or just, you know, ones that are more kind of implementation detail stuff don't show up unless you ask for them, kind of thing.
I think
But at some
this-
point, you're still going to want it, just like you have the kernel module
Yep.
configs. I need to tune it this way. I still need to be able to tune it. So
Yeah, and so the property will still be there. It's just when you do a get, should it give you everything by default or not?
there is already a source for each option, whether it was received, whether it was set, or it's default
Inherited,
one.
yeah.
If we could just simply filter show me everything locally set, it would be dramatically easier to read. It would be just, instead
Yeah,
of
or
100, it will be like 5.
even just like
properties.
filter out all the ones where the value is the default.
That's a good point. That's too easy.
I know a lot of times, rather than using Git to see those type of properties, a lot of times I'll specify them as column options on a list.
Yeah, doing ZFS list -o, a bunch of properties, and being able to get it kind of in tabular format. And you can do it as rows instead of columns if you do get, comma, separated list of things on a data set as well. But, you know, they can get unwieldy like when there are all these properties. Like for VDEV properties, almost all the ones that exist right now are read-only like metrics. And as we've started to add more, it's like, well, at what point does it make sense to have them? And also, like, when we looked at failfast, it was, this one's, you know, it's not an enum where there's just a certain list. It's like it's almost a bit field. There are these 3 different times that you might want to fail fast. And like, do we try to have a comma separated value supported list where you can kind of list these things? Or do we have a separate property for each one that's on and off? Or what makes sense when you have, you know, this kind of multimodal setting? And obviously exploding the number of properties seems like the bad way to do that. When there's only 3, maybe it's okay, but if there's 8 options that each individually can be on and off, do we try to make a compound property or what? I think Pavel had the same questions doing the per data set rate limiting. Do we try to like limit writes by the bytes and IOPS and whatever all in one property, or do we end up with like 16 properties to do read, write, and total for IOPS, megabytes per second, and all the different metrics at once?
I think we are not a leader at this point. I think I saw some zpool get from QNAP or something. They has custom ZFS and saying they put everything into properties. The list was just endless.
Yeah, and with user properties, I've seen other people that have, you know, the whole VM config is a property in the storage of the VM and things like that. And
It's your performance.
yeah, you can get really long lists of these properties and you know, just storing extra things in them, and it works, but maybe we need, at some point, maybe ZFS get all defaults to filtering some of them out, but then how do you
Get some.
get some instead of all? Yes, or get non-default or something might be some useful helper aliases there, and that sounds like a great project for the hackathon on Tuesday.
Are there a top 3 data set properties that have bitten people, such as normalization or case sensitivity, or something that routinely just gets people? Are we reaching for the mic? Yes, let her rip.
I've been bitten by case sensitivity for SMB shares.
Okay.
Like you decided to enable it and then regretted it, or?
No, I decided not to enable it and then regretted it.
Interesting. Okay.
Probably.
I made it case sensitive, but since it was Windows, it didn't want to be.
So, you know, I mean, it's not a very important issue, but the fact that you can't set UTF-8 only except at creation time means that I have a bunch of data sets that really should have that set on them that don't, because I forgot 12 years ago, and now because we've, you know, migrated these data sets to new servers over time, it's like it's still set wrong. Mostly our users don't notice, but it's one of those things that bugs me because I would like to make sure that they don't unintentionally create new files that don't have names in UTF-8.
So would a send fix that, or
yeah, I
not?
was just wondering, is that one where if you snapshot it and send it and override on the receive side to force it to UTF-8, that it would fix it, or would it make a mess?
You can't turn UTF-8 only on except at creation time.
Right, so if you're doing the original, if you're doing a replication and you're recreating it, at that time you could, and then you would copy all the existing data? Of course, you probably don't have room to duplicate all your data.
Yes, so I mean, so you know, the issue, I don't know, I don't think I've ever been in a situation. Maybe we could. I'm not sure if I trust.
Well,
that
I don't know that
happen.
send will do the right thing to munge existing names into UTF-8.
Yeah. Yeah, I mean, probably it would not, and you'd end up with a bunch of names that were either just invalid or.
You don't receive into a data set.
Yeah, when you receive a full replication stream, it makes a new data set. So it's creation time, so you can set encryption and case sensitivity in UTF-8. But I don't know that send and receive are going to do the right thing, specifically the UTF-8 option, because it makes a big difference.
Yeah. My suspicion would be that it would fail if you actually had a bad file name, which is one of the reasons why we don't try to fix it after our grad students have been creating files with abandon. So.
Yep.
Although, I mean, usually they think the file system is just a database anyway, so.
Always start naming them with emojis. Yeah.
And to be clear, it has to be at creation time of the file system is why I got bit by the case sensitivity one as well. And I have never been brave enough to try the send solution. Because I just expected it would slam those two together and not do it right.
It wouldn't be a difficult test, would it? Just
Well,
say?
yeah. If it was sensitive and you wanted to make it insensitive, that probably could work. But the other way around, the first time you have two files that equate to the same name. ZFS probably isn't going to notice, but you are when you go into that directory. Yeah, I don't know what the zap cursor code would do when you had two file names that were the same but insensitively.
Maybe this is a test that should be added?
Probably.
Don't individual files have like an individual UUID to value?
So the way a directory works in ZFS is it's a key value store of the file name to the inode number or the object number. And so you would have two different entries that point to two different numbers. But when ZFS is looking through the ZAP, looking for the file name you asked for, if it's searching case sensitively, it'll be okay. But when you do case insensitive search, you might find the other file that is spelled with capital letters instead of small letters and read not the file you were trying to read. Or if you RM it and ZFS removes one of them, does it stop or does it keep searching? And does it end up removing both or one or none?
I would guess listing ZAP should be working, but finding specific by name may not.
Yeah, I mean, you try to look up a file in a directory by name, like when you try to cat the file, it might do the wrong thing.
There's something you can do like a reverse dedupe. Saying, hey, I'm looking for dupes, the file names are the same.
You could script that, look for the ambiguous possible files, and put a little prefix or suffix and just let her rip.
Samba's worked fine with case sensitive for me. it implements the insensitivity on its side instead.
There you go.
But
So-
it probably has a performance impact.
So I've never been tempted to do case insensitive because, well, we don't have any Windows users. At least not that we allow to use NFS. So I'm curious, how is case insensitive actually implemented? Does it actually use the full Unicode case fold algorithm, or is there some simpler hack?
I think in the ZAP layer, it's just an extra flag, and when it does the comparisons, it's not. I don't know if it's folding or what it's doing.
It translates from how store it into internal representation for comparison, but I don't know the algorithm how it does it.
I don't think it's very well used.
We have some Delphix folks, and I heard a comment like, we don't worry about disks anymore. Are database folks generally completely insulated and isolated from all these issues? It's not that
No,
big a
it's
problem?
not that. It's more like we run on VM, so run on ESX and on the clouds.
Okay, so on VMs and on the cloud, and so
Yes.
you're generally I'm guessing in a foreign file system on ZFS, be it ext something, or?
No, it's more like the disks that are provisioned to the VM already
Okay.
have some sort of RAID.
Beep. Beep, beep.
Yes, like we're running on EBS, for example, right? That, like AWS already has that.
Battery trouble.
Get under the table.
Cool. And are there other circumstances where databases or otherwise, it's just not a problem and you don't have to worry about these things?
Yeah,
Like
sorry, go ahead.
Maybe talk about the fact that they're backed by SANs.
Exactly. That's what
Sandbagged?
I was saying. Right. I don't think it's a database that doesn't need that. It's more like the storage that is presented to the VM already has kind of the redundancy protection.
Cool.
So that means that most of your deployments are not using like RAIDZ at all. You just have one VDEV.
Correct.
Do you ever see checksum errors from the SANs?
I don't remember that being a big problem for us. I don't think that comes very often. Yeah.
And we had one case with, I forget which customer it was, where they had, I think it was a pure storage backed thing for their VMs, and they started getting checksum errors, and they had deployed their TrueNAS with just one big VDEV that was from the VM, but yeah, eventually they did figure out that it was a firmware bug in the flash storage that was meaning that every once in a while they wouldn't get the right data back. So we rebuilt
Disks
the
lie.
VM.
Even if they're virtual, disks lie.
Yes, or especially if they're virtual.
By definition, they're lying. We have about 10 minutes for story time. Did I see a hand in back?
Just a recent
Yes, sir.
curious.
Number one?
So we're running on AWS, EBS, and so we're doing the thing where there's just one VDev, and we just create the pool directly on top of the EBS. And one of our operators was resizing the EBS sort of dynamically, and I guess we thought that was okay for years. But it started causing some issues. I'm curious if anybody else ran into that.
I don't have firsthand experience, but I've heard tell that when you resize, kind of underneath on the EBS side, it's basically deploying a new bigger volume and copying your data over to it, effectively like you were ZFS sending it from the old one to a new bigger one. And that I'm sure weird things could be happening in the middle of that process until the resize is finished, but I don't know much more about it. The other thing I've heard recently is that, you know, EBS volumes are actually have kind of like sub-partitions in them, and that each chunk has its own, applies the IOPS limits itself, and like a limited queue depth. And so if you're doing all the I/O to one subset of the EBS volume, you might see less performance than if your I/O was spread across more pieces of the EBS. Was there a specific problem you were seeing, or?
I have to go back and look.
Okay.
How large is it?
It was probably under 20 terabytes, maybe.
If it was that small, that shouldn't be a problem.
There's another thing we've noticed where the same operator was detaching from one instance and attaching that block store to a different instance and thinking that everything would be okay. What we noticed in practice on AWS is that it's almost like that system isn't near until you've sort of exercised the disk for a day. And so like the next day, the whole thing appears to be close to the instance, whereas up until that point, it's like you could request something and it's like, well, let me go fetch it for you. So curious what might be going on there.
Yeah, especially like if you're not careful to launch the instance you're going to attach to in the same availability zone as the source one, then it probably is under the hood, you know, relocating that data from one building to another building that's closer to where your new VM is. I know Delphix also implemented the zpool initialize feature.
Was it
because
either
they found
0 or something?
Yeah, they found that EBS volumes, when the first time you wrote to each sector is when they provisioned that. And so the first write to any sector took longer than before. And so when they first create the instance, they would go and basically in the background write out a pattern of something other than 0 because it would get compressed away to every sector, so that when you go to use it for real, the latency is going to be the normal latency and not the special, this is the first time latency.
Yeah, you get the volume, but you get it on paper. And then eventually.
It's basically like if you're using VMware, it's thin provisioned.
Yes.
And so they're not actually allocating the storage and deciding where to put it until you use it. And so use the whole thing up front, and then when you go to use it later, it'll be a consistent latency instead of, you know, the same, oh, this is a new one, and it's going to take 4 times as long or something. But yeah, you know, virtualization is just layers of lies.
It complicates everything, I know.
Pool compatibility. Recently had an exercise trying to recover system from a backup, which was ZFS on FreeBSD, I think 11.3 or something like that. I take 3 or 4 attempts to recover, but neither of those booted. Even after I set pool to everything disabled, completely generic pool v28 or whatever, it still was not booting on created on newer FreeBSD, but wasn't booting on 11.3. And only when I booted 11.3 and created a pool, after that everything worked. I still don't know what was the magic and why old loader and newer ZFS weren't compatible, but it weren't in features. But I still have no idea why would that happen. Obviously,
Yeah, I don't
loader
know.
is not very verbal to say.
No, the loader is not. Using the user boot or like the beehive load, which is the loader compiled to user space, you might be able to trace it or add more printfs and not have to keep rebooting to try it.
Yeah, maybe.
Because I've used that as a recovery tool once before, where the pool was damaged enough there was no way ZFS was going to work with it, but the loader is just dumb enough that it will just try the reads anyway, enough to get back, the SSH keys and a couple of other files from etc that I wanted back to rebuild the same machine.
Well, anything else? Any final thoughts? Or shall we jump into about a 12-minute break? Thank you, everyone. And Patrick, maybe bring that camera back just to get the intro-y stuff. Welcome back, everybody. Let's talk storage, LAN, and WAN networking. The N in NAS is for notorious. So I just got nasty. I grabbed a random quotation here. 1984, the number of internet hosts has surpassed 1,000. Now we all have like that many VMs in our basements. So I wanted to just kick this off based on some recent conversations, frame it, and let her rip. I heard a comment that this is why I'm here, so we will dive right in. Number one, let's please stop making the same mistakes. We'll touch on a few of what those are. Number two, stop blaming your storage system for every network issue. And I've noticed that when you bring in a new open source based solution, people immediately blame it for everything. The coffee maker doesn't work, it must be the NAS. And from a recent conversation while setting all this up, do not build the highway for your 2 a.m. traffic pattern. Thank you very much. The telecom industry is famous for over-provisioning. We internet nerds with our open source OSs are trying to squeeze every possible oversubscribed dollar out of everything. So when you have that nifty gigabit service that showed up in your neighborhood, people start watching their favorite shows and you name it and talking to grandma in the old country, and suddenly your gigabit is about 300 megabit if you're lucky. So over the years, we've all bumped into jumbo frames and people thinking they are the panacea to all things networking. And I got some great feedback. Okay to read this, Rodney? Okay, so I'll read it back to our author. So, jumbo frames, they are meaningless on the LAN. Things were expensive back in the day when sending 1,500 byte packets was a challenge because CPU overhead would simply not keep up. But now we have offload engines. They get assembled up in a big old 64K byte packets, and you may still have issues when you go into, say, UDP traffic. We can get into this too a little later. 188 byte packet size and grouping with like 7:1 ratio of packets. VoIP people hit this. Users when they're doing their magic with voice over IP. And what they're doing is aggregating to a single UDP packet at that ratio of 7:1. Now, things get a little trickier when you're pushing under 1,500 byte packets. Some workloads will, with, say, that audio, be a whole lot of little packets and not be what we're discussing. I will leave that to the experts, but we are not living in the 90s. Let's not configure our networks like the 90s are here. So, a little further down the stack is the VPN encapsulation and MTU rules. Those still crop up, but that's not saying just jump into jumbo frames. And one quick thing about a big old MTU is that each device might redefine jumbo very differently. Related in that networking is now the fact that SMB and NFS have some notion of multipath. And there are very different use cases of hitting a NAS with a user or an application, or wholesale data center to data center replication. Very different use cases, very different requirements. A lot of LAN for one, a lot of WAN for the other. And naturally, people think, let's aggregate all the things with LACP and other link aggregations, or, wow, there's now a Latvian-made 100 gig switch, 16 port for $2,000. I hope that that can solve some problems for you. And true eyes on the prize, what is that formula we should always use to match your network packet size to your ZFS record size on disk? Garrett, it sounds like networking brought you here. What are the challenges you are trying to face on mic number 4?
Well, thankfully, mostly none of these. But certainly some of the things from the previous slide is we have users with the one before. We have users with let's say a wide variety of access networks. Anywhere from 200 gig down to 1 gig. And, because our users are university researchers and they're cheap, generally the newer stuff tends to be faster, but that doesn't necessarily mean that they will invest in the network infrastructure that their newer stuff is connected to. And so they blame me because their storage is slow rather than because you're still on a 1 gig switch and you're sharing it with 30 other nodes. So that is certainly like the biggest issue that we have. But we've also noticed that even when the network itself is pretty unconstrained, it's pretty rare for our users' actual loads to be anywhere near the network capacity. Unless it truly is a 1 gig access network, in which case, yeah, they can just totally saturate that easily. But for most of what, and again, this is kind of like our users are mostly machine learning / computer vision people, at least. Well, those are the ones who actually have the petabytes of storage, like everyone else is kind of in the noise compared to them. And one of the things that we've been trying very, very hard is to get them to understand that round trips cost. And so much of what they do is opening 100 million files one at a time with like a 15 directory long path name. And do you know how many round trips that takes in NFS? And and again, they think, oh, the storage is bad, but no, the storage is actually, it's not even noticing what it is that you're doing. The storage is perfectly happy, but the network is eating all of your load times because you are trying to read 100 million tiny little files in a way that can't be cached and in a way that basically maximizes the number of useless round trips. I have tried, for example, to get people to do things like, hey, instead of turning this, MPEG-4 file into 100 million individual frames, why don't you just create an index so you can seek in the MP4 file and read the frame out as you need it? Because if you're holding the file open, seeks are free. But unfortunately, as I mentioned before, there is no API for grad students. And basically, grad students will do whatever the cheapest, simplest, easiest to find on Stack Overflow thing is that gets them towards the next paper and eventually towards finishing their thesis. and mostly the faculty that they work for don't want to pay them to re-engineer their ML pipelines. They want to pay them to discover new stuff. And that makes it very difficult unless we have some new faculty for whom that's actually a little bit of an easier message, because they've come from other institutions where they were already forced by lack of resources to do some of this work. But mostly because we can't control what the users do, the users tend to do the obvious, easy, but most pessimal thing possible, which of course they don't notice as a problem, because if they test it out on their laptop or whatever, it's fine. There are no round-trip delays on their laptop, at least not that they can measure. But it gets pretty bad for NFS.
I will reinforce that with a quick motto of the center, which is, we've always done it that way.
Yeah, an interesting one that we came across was a customer that was making a backup product that did disk imaging, basically, but over NFS. So on ZFS, they would have a raw disk image of the whole hard drive from before, and then they had like a Windows block layer driver that would figure out which blocks had changed, but effectively, they'd be doing a DD of the hard drive from this machine and writing it over top of the existing file over NFS, and using ZFS's not write feature, which notices, hey, the checksum of the block I'm about to write matches what's already on disk. I don't have to do anything. And so they were just overwriting the whole file with a newer image of the hard drive, and they would only have to write out the bits that actually changed. So most of the benefit without, it's going to use up the network needlessly, but the disk storage space, you get the advantage of almost of dedupe, but without the overheads of dedupe. The problem was the NFS client was sending 64K chunks, because that's the default size in NFS. But their ZFS was configured for 128K record size, because that's the default there. So that meant they would overwrite 64 of the 128K of the first record. So ZFS would have to read the whole 128K off disk, do the memory copies to combine that into a new 128K block, calculate the checksum, realize it's the same as what's on disk, and throw it away. Of course, they had, because their workload is linear, they're like, well, the ARC isn't going to help us, because we're not going to keep every disk image in cache. So we set primary cache equals metadata, so no caching of the file. So now when they write the second 64K of this multi-gigabyte or multi-terabyte image, they have to read that 128K they just read a minute ago again off disk, do the mem copy to do the second half of that record, calculate the checksum, find out nothing's changed, and then not write to disk. So now they're sending 128K over the network, reading 256K off the disk, and then doing nothing. And repeat for most of the disk image and only writing out a couple of blocks. The ARC's going to make sure that, or the way ZFS transaction groups work out, we're only going to write the 128K once. We're not going to double all the writes, because it notices that we just overwrote the block 2 different times in memory. But it was, a lot slower than it needed to be, just because the NFS record size and the ZFS record size weren't aligned. And when we made them rewrite all those images with a new ZFS data set, and suddenly everything was many, many times faster, they were like, you mean that one setting was all of our slowness?
Did you reduce the data set to 64?
Yeah, so we changed the data set record size to 64K, because it turns out they couldn't control the NFS on all the various clients they had. Right? If it was just Linux workstations that they controlled, they could have forced NFS to use 128K and been happy.
And it will do it, okay.
But all the different clients were running different things, and there was no way they could try to get all their users to actually configure their NFS properly. And so they had to try to fix it in ZFS by just using a smaller record size.
So I have another issue, which gets closer to the actual ZFS stuff. So we basically always turn compression on, because that's kind of what you want most of the time. There's a bunch of optimizations you don't get. Like, I think the not write one is one of them.
Well, so not write by default is not enabled if your checksum isn't stronger than Fletcher.
And one of the things that happens when you have compression turned on is that writes into a nearly full data set get extremely slow.
That's not compression's fault. That's the quota system and the amplification thing.
Okay.
There's some improvements in newer ZFS for that we wrote.
Okay, well that would be good to see.
Yeah.
So this interacts badly with the way the FreeBSD NFS server works. The FreeBSD NFS server, when it starts up, will look at the sysctl for what is the biggest possible TCP buffer I can have. And it will just force all the socket buffers to be that big. Now, as I mentioned before, we have some users on 200 gig and some users on 1 gig. This is a problem if you're all going to have the same size socket buffer. And it's a particular problem if sometimes writes get really, really slow, because that means that you have some users who can basically exhaust all of memory on your server without not even intentionally, and crash it just by writing into a nearly full file system. And of course, they don't pay any attention to stuff like, is this file system full? Is this file system close to being full? They just, they wrote their batch job 5 years ago. They're now about ready to publish their thesis. They need to run these results. And they just start it, and then they go off and have a life. And the job keeps on running. And eventually the server crashes, and I get paged. And I think, between that and sort of the somewhat, because that also causes the noisy neighbor problem, which is one of the reasons why I now have approximately 20 servers and not like the 5 or 8 that I really would prefer, is because the users don't want to be in a situation where someone in some other group could use up all the capacity of the server and then they can't get their papers submitted in time. Because, especially, again, as I say, most of our big users are machine learning, computer vision. There are 4 big conferences in that field. All of them are submitting to those conferences. They all have the same deadlines, and they all need to get their work done simultaneously, which is why they all have their own servers now.
Yeah, one best practice for that case for sure is creating a data set with a reservation to save that last terabyte of space for me and to make sure that the users can't actually fill the pool all the way. And then obviously data set quotas and so on to try to keep people
we've never had an issue with the pool getting full. We don't let the pools get full.
Right.
We have the issue when the data set gets close to quota.
Right, yes, in the quota, part of the problem there is ZFS, when you have data that's in flight that we haven't written to disk yet, ZFS assumes it might need the worst possible case, which is 12x that amount of space to write it out, because you might have a RAIDZ 3 with copies equals 3 and all the other possible things that could happen where that would take a lot more space. And so when the amount of data you're about to write times 12, it reaches the limit of how much space you have left, ZFS stops and says, we have to flush this out, actually write it to disk, and see if we have any more space so that we never accept a write for where we wouldn't have room to actually write it out.
And that's why all the writes get serialized and performance goes to pot.
It causes the noisy neighbor problem, whereas because you're doing a pool-wide transaction group flush, you're now one data set being near the quota is affecting other people who aren't anywhere near their quota. And it can really damage stuff. And so with our changes, we have I think it's a setting where they can go like 3% over the quota with the inflation in order to try to smooth that out and not have it just murder performance for the whole pool just because one person is near their quota and is trying to write. But we had to do a different version of that patch for ZVols because ZVol has a fixed size. You're never actually going to be able to go over the quota. You're always just going to be overwriting existing data, but it still applied the same effect. And so your ZVol could get hit with this performance and drag down the whole pool for no reason.
Thankfully, I haven't had to deal with ZVols in a very long time. So
Garrett, for your students, right, is throwing more networking gear the solution to solve the 200 gig versus 1 gig problem? Is that the only solution? Because
Repeat the question when you're.
Yeah, so your Geshe's question was, is throwing more network gear at it and actually just not having a mix of 1 gig and 200 gig a solution to that?
To some extent it is. That is, what we've been trying to do, but that means, getting faculty to spend money on something other than GPUs, which is not always easy. I think some people recognize that it's necessary, and others, it's like, why am I paying for this? Isn't that your job? Or something like that. Because 1 gig historically for the past 20 years, 1 gig is what we've been providing them. One of the issues, though, is that a lot of times they want to be able to do the same compute in the data center as they do on their workstations in their offices or labs. And I'm not putting 200 gig in every office.
No.
So,
One of the things we've done in that scenario is actually have a tax that applies to networking gear. That if you're buying X amount of storage, we take 8% of that budget and put it toward networking. Yeah. And it's isolated out, and that's part of the whole cycle and tricking it to, hey, you just got upgraded, so everything works better.
Yeah, it would be great if we could do that. We already have a lab tax, and that's what pays my salary. Right. But again,
you need a bigger salary too. So
well,
we can
yeah.
increase that tax, right?
But and one of the things that's sort of a administrative/organizational concern for us in a university environment is that when people are sort of looking at their budgets for grants, if one institution, is charging, 75% overhead, and we're over here charging 85% overhead, then that's going to necessarily reflect badly on our researchers when they are applying for grants. And that also means that, ultimately, if the grant amount is fixed, that they're going to be, that's money they can't spend supporting their students if they're giving it to us. And, when they buy hardware, when they buy capital equipment of any kind, which is, these days, it's over $5,000 is where we've set the threshold. They don't pay tax on that. That is exempt from institute and lab overhead. And so they have like a really strong incentive to make sure that whatever they buy is over $5,000. Because it's literally, if they buy $4,000, it costs them $8,000. If they buy $5,000, it costs them $5,000.
Alan, could you educate us, please, on when the checksum algorithms matter? I've heard it mentioned with the NOP right a second ago, and I recall ZFS diff behaving differently depending on the algorithm, giving you more or fine-grained information or something.
I don't think ZFS diff has any difference, but yeah, so the NOP write, where if the incoming write has the same checksum as what's on disk, you just throw away the incoming data. Requires SHA-256 or better because it assumes the chance of a collision on Fletcher 4 is too high.
Interesting.
I don't know if anyone's ever proved it to see. Maybe it's overly cautious, but yeah. And the interesting thing is, with most CPUs now having support for offloading SHA-256 or 512, you know, you probably can get away with using one of the more expensive checksums without it actually being that much more expensive.
Actually, somebody requested just yesterday or 2 days ago on our OpenZFS issue to enable NOP-RAID for the weaker algorithms with verify optional.
Oh yeah, a verify option.
Yeah, but that actually made me quick look on a verify code, and I found it pretty much synchronous. Which wonder, did you hit it on your tests, or like how it performed in that context?
For dedupe verify, you mean, or?
No, for for NOP-RAIDs, you
Ah,
said.
for the NOP-RAID, we were using SHA-256 with no verify.
Ah, so it was reading just to fill the blocks, but
Yeah.
not to.
Yeah.
So honestly, I don't think I have set up a single system in at least 5 years that used any of the weak checksums. Because like, why bother? I have lots of CPU.
It's never the bottleneck.
Yeah.
Right.
Are all of our Z pools still being created by default with Fletcher?
Fletcher 4 is the default, yes.
It is the default. So that, in other words, hardly anybody's using the no write feature.
Yeah, nobody's else. Yeah, most people don't have NOP-RAID because of that. It was interesting for a while. It made more sense that if we would set a default, we would go to SHA-512 because it's got about 50% more throughput on 64-bit when you're just doing it on the CPU. But now that CPUs have special instructions for it, the SHA-256 might actually be faster. And it does seem almost like, you know, checksum equals auto, and it picks which one of the strong checksums is the fastest on your CPU would almost make sense there.
Do we have offload supported on all platforms?
I don't think it's supported on all platforms. I think we have offload for Intel and AMD.
No, I mean
and
for FreeBSD Linux. Or I don't remember when it appeared.
Yeah, I don't know. I got it hooked up on FreeBSD on the ARM V8 version of it, but I don't know the status of all of it on every platform. And it seems like we should get that ironed out.
Do we have x86 SHA-256 offload?
I think so.
Has anyone done science on that? Like in 2024, with your average CPU on your average new server?
Well, what's your average CPU in 2024?
It
like,
does vary.
My older
but the
Intels
feature
don't
flags-
have either. But
Correct, but
an AMD of the same kind of vintage probably does.
and these are data set properties, not pool level, such that you could
Yes.
say, hey, my checksum algorithm for this, this, and this is this.
And you can change it on the fly. It just only applies to
The new-
blocks written after you change it.
Who needs a hackathon project? Just some
So-
simple tests, just where
so-
are we at?
So if I can ask a related question, so what checksum is used to protect the pool data structures that aren't specifically in data sets?
Metadata, perhaps?
I don't know. I think it's Fletcher for most metadata, probably.
Yeah.
Or does it inherit from the data set still? And the pool uses the root one? Well, one of the biggest mistakes we made in ZFS was allowing the root data set and the pool to be conflated.
Yes.
But yeah, the root of the pool shouldn't have been a usable data set. That was very much a mistake. There's a special really weak checksum for the label, but I think beyond that, everything it uses, it uses the one from at least the root of the data set or that data set. But that's a good question. Even if you set SHA-256, is some of the MOS blocks, are those actually written with that checksum, or do they just use the default checksum of Fletcher 4 no matter what?
I remember Fletcher is hard-coded in some places, but I don't remember where it's for all metadata.
Yeah.
So definitely, they have different settings for compression. Metadata always compressed,
Yeah.
even if you set disabled.
Yeah, like I think we even removed the ability to not, there used to be a tunable to not compress metadata.
Really?
Never said.
But that got removed a long time ago. And you know, we were wondering about that again recently when we had some metadata corruption. It's like, at least if it wasn't compressed, we could read some of it. But anyway, that's a good question. I don't know the answer off the top of my head.
We have a YouTube question that's completely off topic. So, would it be possible to implement a feature that lists all holds in snapshots by volume? For example, ZFS holds as a command and hold name and volume, if that makes sense.
I think
How
at
do you
one
list
point
holds
on
currently?
FreeBSD I added like holds -r that could recursively look through a data set for any holds. Are they looking for all holds with a specific name or all holds on a specific snapshot?
All holds in snapshots by volume. Is there wording?
Yeah, so probably.
Okay.
And I implemented a version of that at some point on FreeBSD. I don't think that survived the transition to 2.0, but I had always meant to go back and do it differently anyway. The way I wanted to do it was to be able to do that holds, but also to specify a range of snapshot names using the snap spec to find all holds in a certain range recursively across many data sets. The confusing part from that YouTube question is the word volume, since there's no such thing in ZFS, and what that means to people is different all the time, and it always confuses me.
Yeah.
I doubt it means a zvol, and I'm guessing they mean the whole pool, but it could mean many different things.
Now only by snapshot is what you just came out
Right. I think for one specific snapshot, that's what I did implement at some point. So holds -r and then a data set at a snapshot, and it would let you see all the holds on that snapshot, even if it was recursive across child data sets.
Just adding on that, why have we been, so if you look on the community, like, to get snapshot sizes, the actual size of a snapshot, it's always a pain, right? So you have to do -n, -b, to do like a recursive, to get the actual snapshot size, but -o space does not give you the right size. So why have we not given like just a simple command? Okay, give me a list of space that, space that is occupied by snapshots, so using the ZFS command.
Yeah, so Yoges's question is, when you do ZFS list on snapshots, the used column will show how much data is unique to that snapshot, which is effectively how much space you would get back by deleting that snapshot. However, if there are blocks that are shared by 2 or more snapshots, that size doesn't show up on either snapshot. So if you have, your 2 oldest snapshots and each one says you'll save a gigabyte by freeing it, by deleting it. But if you delete, and if you try to delete one or the other, that's how much data you get back. But if you delete both, you might actually free 8 gigabytes because there's blocks that are shared between the 2. And in ZFS list, there's no way to, like, ZFS can't figure out who to blame for that data because the answer is multiple people. And so it just doesn't show it at all. And the size you get is how much you would get if you delete that one. But to figure out how much you would get by deleting a range of snapshots, the only way to do it is run the ZFS destroy with verbose and no-op, and then it will do the math and tell you. But it's should there be a better way to just figure out how much space you would get by deleting that range? But the problem is, how do you specify that range? Or maybe there's a way you could tell from per snapshot, but it would have to be what other snapshots are you willing to delete? There's not a good way to do it, and that's why it doesn't exist, but it is very confusing to the user.
It seems like at least there could be a property that shows the size of shared blocks included in this snapshot.
Maybe. Yeah.
shared with other snapshots.
Yeah.
But you have to go through every snapshot that exists to maintain that as it changes.
That's when you do the non-destructive
Mm-hmm.
operation, you get the real number of proofs.
So by default, the columns you get are used for how much you'll get back by freeing that one, and then refer, which is the total live amount of data in the snapshot. And then there's a hidden property called written that tells you how much has changed since that snapshot, but that's not the answer either. So maybe another hidden one like written, but I don't know the mechanics of it.
I mean, the reason I brought this up was this seems to be a very common problem.
Yes,
Everybody faces that.
very
And,
confused.
We don't have a solution for after all these years, so that's maybe a useful thing to add.
Is there anyone here not familiar with the written property? God's own property? Alan, can you describe a few more aspects of written, because
I don't
it's-
remember the mechanics off the top of my head, but it's a way to tell how much of the data in this snapshot has been replaced since it was made or something. It's useful to know, but it isn't related to how much space you'll get back for deleting it.
correct, but it's very useful to
Yeah.
know.
Yeah,
No.
if you looked at like, my bash history on any one of my servers, there's always ZFS list -o name used written refer, because that's basically the thing that I need to look at, managing to try to figure out what the hell these users did that they've run out of space that I can delete.
I had customers coming back to me saying, hey, I have like 10 terabytes of used space, used by snapshots, and I'm gonna tell them, okay, if I delete those snapshots, why am I getting more space for you? That's the same question you answered, right?
Yeah.
It's stored more.
To the holds thing, that's actually fairly simple to script away. I know I've done it before. I don't know if I actually wrote it down anywhere, but I'll figure it out again and post it after the end of the conference, though, on one of the things.
Yeah, but I think the advantage to building it in is that you're making fewer round trips to the kernel and can make it a lot faster to get that list.
Absolutely.
Mhm.
Not disagree.
Yes.
I had something of I may have missed a chunk of it, but if you were trying to figure out, going back to the example, if you've got two data sets, they're both sharing some amount of information, or some amount of data, and you don't know, where this phantom data, whether it's going to be 8 gigs or a terabyte or what have you. Why wouldn't, as a quick and dirty way of figuring out, cloning them out and then deleting those two? Would that
So for clarity, these are not two different data sets. They're a series of snapshots of one data set.
Oh, okay.
And so,
I see.
So if you, wrote some data, took a snapshot, write more data, take a snapshot, write more data, take a snapshot. Anything you deleted before the third snapshot is now in both the first and second snapshot.
Okay, that makes more sense.
If
Yeah.
deleting any one of those snapshots will only delete the files that got deleted during that snapshot, but deleting both will now cover anything that was deleted after both of them. And so there's this kind of third amount of space that suddenly comes back, but only if you delete both. If you delete either one of those two snapshots, you'll get back only what it says you will. And then the other confusing thing, to Yogesh's point, is when you delete like the middle one, the size of space you'll get back for the other ones will adjust, because now that data is only referred to by one. And so deleting this snapshot made the one above it suddenly report that it's bigger now, because that data will suddenly actually be freed when you delete it.
Cool.
And so, yeah.
Terrifying, but cool.
And just doing the ZFS destroy no-op is definitely a lot faster than cloning it and making a bunch of changes.
I know we kind of got into data sets and the topic kind of started with LAN and networking, but so I'm kind of going to throw it back that direction. As we know, when you're dealing with the storage arena, which is kind of my area, I spend most of my career disproving that it's the storage. And that's just, and everybody knows. When you say it's a network problem, what do they say? No, it's not the network. I mean, you know what I mean? And then you spend hours and days trying to prove, yes, MTU set wrong. Maybe they didn't flush the router cache. Maybe they had the wrong route. I mean, you end up having to prove it. So long story short, coming back to ZFS. It seems to me that there's kind of this ongoing battle and discussion of whether we should just use iSCSI or whether we should use the way that ZFS presents it
NFS. It seems the latter is another layer of abstraction, which is going to be slower, in my opinion. But I'm just curious, like, going to throw it out to the council as far as a discussion point, people's experiences, specifically to kind of make it a little more focused, is, you know, in the virtualization world. Everybody's using VMs or containers or something nowadays. So in one of those environments, now you've got the beavers versus ducks situation of, are we going to use iSCSI or are we going to use NFS? So from my perspective on the storage side, when the system receives it, the file system is just going to do what it's going to do. ZFS is going to do what it's going to do. So I can't really think of any specific network criteria other than just try to, based on your environment. But that's why I'm wondering, is there something maybe in your experience or other people's experience in the virtualization world where maybe there's something that in the NFS area that's better than iSCSI? That's what I'm asking.
So, you know, I can say specifically, my users want files, not blocks. For the backing store for our OpenStack cloud, which is a different part of my group that thankfully I do not have to touch, that is all actually Ceph, because OpenStack really wants blocks and not files. And we actually, before we deployed that, we had some like Dell weird ass iSCSI storage platform. And, you know, basically, you know, every time there was a little blip on the network, that basically destroyed everything that was using it. Because certainly, at least in like, you know, 2014, you know, Linux iSCSI initiator just absolutely sucked. And particularly sucked when it came to dealing with network issues and other kinds of like intermittent things. And so, you know, that experience led us to something that was not iSCSI because we cared more about reliability. You know, we're a very small team. We have basically 5 people supporting 1,200 people. And that really meant that we needed something that was more reliable. And we didn't have the budget or the ability to go out and, you know, spend $1 million on a, you know, a EMC or Isilon or whatever. So that was the solution that the virtualization guys came up with. And, you know, my users, you know, again, you know, they're machine learning people. They just want 100 million files that are all accessible to all of their compute nodes and that they can write to, or a place that they can store checkpoints to and then load on another compute node later without having to like spend an hour before every job of, you know, synchronizing things around, which is what like most people in big HPC environments do. Is, you know, their pre-job environment is move all of the data to the compute node, and then their post-job job is move all of the results from the compute node back to someplace that I can get to it. And our users would basically, well, they would hang me if I made them do that, so, which is why we do NFS for them. I wish we could do something more secure, because right now we have a number of users who have, they don't have regulated data, but they have like regulated adjacent data. And for them, we basically tell them right now, okay, you have to go and buy your own storage server and buy your own network, and we'll build a private network for you that you can put this data on. But, you know, most of our stuff is on the internet. You know, literally all of my servers are on the internet. I can get to them from here. We do block NFS at the firewall, but.
Well, it sounds like your environment's a little more niche because you're dealing with issues. But I'm sure other folks have, you know, VMware, Proxmox, Hyper-V or something, and I'm wondering if anybody else has any experience in that on the virtualization side, whether or not how they've set it up.
No, I'm not so much an administrator, even so I had some of my own VMs for development and things. Well, I have some small production, but not big. On NFS, I did like to store files as files, even so in case of VMware files are only VMDKs. It doesn't store end user files, but it is slightly better than nothing if I need to restore one VMDK from backup or one VM from backup. That's much nicer. On the other side, NFS only, either NFS or SMB only recently grown copy file range, only recently grown, I think, hole punching that was never supported, which were for iSCSI supported long before. So Xcopy was supported for, I don't know, 10 years probably. Trim was supported for another 7, 8, 7, 10, I don't remember how, but was supported for a while. For NFS, it was third-party protocol extensions that require some plugins here and there and were ugly. We were trying to do that as plugins for TrueNAS, but that required to be written on Java, installed on VMware site. Third-party protocols working through several different RPCs with NFS. That was not very convenient. Now, definitely with NFS growing to 4 point something, we have server-side copy. I think we have hole punch and should be, I don't remember, but server-side copy definitely do. And with that, maybe air gap will slightly close. Yeah, the one annoyance that that NFS always require in implementation of VMware is always require for sync always, that for many people create confusion and reduce performance. But to be fair, iSCSI required to be set on server sync always, otherwise you wouldn't get reliability. So it's some more like user understanding things, even so they are not so dramatic in practice, not real difference.
Where do you want your control point?
Right.
That's what it comes down to.
Yeah, like I've seen in production every different combination. One of the customers, an engineering firm, uses like each of their ZFS systems is basically one giant ZVol. They export over iSCSI, and VMware formats that as VMFS and puts all the VMDKs in it. And then ZFS means with compression and so on that they end up with more space than if they just use something not other than ZFS. And that works well for them. A different customer runs backups and so on, and so they have NFS and they just put all the VMDKs on it. They don't do as many data sets as I tell them to, but they have at least more than, it's not all just in the root of the pool like some other customers.
Are the VMs live in that pool?
Yes. Yeah, so these are a VM that's live that's just running the Veeam software to receive the backup and write it to that VMDK. And similar. Another customer is trying to have their system orchestrate to have a separate iSCSI volume for each VM, but it means that when they create a new VM, they have to orchestrate creating those ZVols on the ZFS machine and exporting them and then connecting the right ones to the right VM. And
multi-tenancy, that's a good thing.
Yes. And in general, like it gives you a lot more control over who's using how much space, and you know, oh, if someone's data is more compressible, then maybe we let them have more space than the person whose isn't, or just being able to use the per dataset stats that ZFS gives you to know which VM is making my storage busy, and maybe using Pavel's rate limiting to keep the noisiest neighbor down to a dull roar, and so on. But yeah, a lot of them, the reason why they go to NFS over iSCSI is the coordination of creating a separate ZVol for each VM is really difficult. Like I think Proxmox has a plugin that tries to work with TrueNAS, but it's a big block of Perl that doesn't really work very well. And short of having something like VMware that can do a VMFS to take one ZVol and chart it up to a bunch of different VMs, NFS seems to be the lower overhead on the orchestration side. Haven't done enough benchmarks to tell you that, you know, iSCSI versus NFS, one of them is a lot faster than the other or anything like that. But like Mav said, especially if your NFS is older and doesn't support, you know, trim and hole punching and so on, then it might be a problem. And of course, with Proxmox, if you're doing hyperconverged where the storage and the computer are on the same node, then it's easy to have a separate ZVol for each VM. But you know, you don't have the ability to migrate the VM to another machine easily.
So in theory, if you're using NFS and you have delegation turned on in v4, then you might actually get some advantages to that versus having a pure block interface, simply because NFS can tell you, hey, okay, you can just cache this and flush whenever, as opposed to the way
Although
typical
iSCSI
block
had
storage.
offloads for things like that to
Yeah.
trim and the server-side copy sooner, but now that NFS is caught up, it might have negated most of the advantages of iSCSI.
We have time for one last question from Andrew. Who's been
Well, not
patiently
really a
back.
question, but
War story.
not even that.
Not even that.
I ran it on iSCSI, which I ran into kind of the same problems of Linux. iSCSI at the time was not great. And so we moved everything to our ZFS serving out fiber channel. And then lately we've been doing NFS, and what we found is if you were treating each one of these virtual disks as not as a block device, not a big deal. If you're treating it where you've got access to the files and handing NFS off that way, then it ends up, at least from what I've seen, to be fairly useful in that your ZFS system now understands all the files. So there's that to consider.
And breaking news, we had a follow-up question from the previous holds question. Alan, I showed you that. Make sense?
Go ahead and read the question.
So why can't one import a checkpoint in read-only mode with another name without exporting the current pool? Oh, a full pool checkpoint.
So you have a
okay.
pool imported that you have a checkpoint of from some point in the past, and they want to import the pool at that checkpoint, read only under an alternate name so they can access the old data without having to export the current one. I don't think any practical reason why you couldn't do that. It's just that ZFS hasn't, the right little bits haven't been wired up to make sure that you don't have the conflict in the name of the pool. Because as Don discovered when we did the, I guess it was for asynchronous teardown of the ARC, when we import a pool, in the ARC, the GUID the pool uses is not the GUID of the pool, it's a randomly generated one. And so we wouldn't actually get the conflict if we imported the same pool twice, as long as the one was read-only and an old checkpoint and not, as long as it's completely read-only and it's hard read-only, that should be possible. And that's probably tractable enough that someone could do that at the hackathon on Tuesday.
Well, let's call it good for there. We will reconvene in about 6 minutes at 3:30. Thank you, everyone.
more conversions, Boston tonight. Yeah. Still good? Hello, Greg, can you hear me well? Yeah. Check one. Yep. Yep. Okay. I am talking. It's a nice day if it doesn't rain. Lots of color in the forest. Still need me to do audio check or yeah, good. Oh no, you don't want my background's my blurry kitchen. Yeah, yeah, I do. Yeah, I'll loosely stay on my lane there. Anyway, hello, I'm Greg. Why not? I work in VFX post-production for a media and entertainment studio in Toronto. I've been a ZFS advocate for over a decade now. We use it in a full production in a previous job, and I came to this studio and I was pitching the idea that we use ZFS to do some of our projects. Is the incumbents that we've been using were Isilon and Cumulo. I just want to talk a little bit about my experience there, and um, these opinions are my own; they're not reflective of my company or whatever, that legal stuff. Anyways, we put together a ZFS system for a project that we started on about a year and a half ago. It was right now, as it is today, it's about 740 some terabytes in size, and that's on a 1 petabyte file system. Whilst the project went well and there was no significant issues, and we started thinking about, can we actually use this in production? And we started reading the compliance compliancy audits that we'd have to adhere to. It turned out to be a bit of a show blocker, unfortunately, which was pretty sad because it was looking promising, and I was thinking I was breaking new ground in media and entertainment, but it didn't turn out that way. So the currently the native ZFS lacks built-in capabilities for doing file access level auditing, such as who opened the file, who modified it, who deleted it, who moved it, and the times and dates and the machine number that it came from. And these kind of metrics are ones that the auditors require. They're a prerequisite for being assigned a project for some of the big studios. Apple and Netflix come to mind. There's others. So those audit logs are crucial for compliance with the security standards. And there's many of them. The one that we're under predominantly is the TPN and the MPAA. And if you're not able to provide a concise, accurate accounting of who did what to what file and when, you could potentially and probably not get awarded that project as a result of that. So I poked around, but this is one of the things that I see as ZFS as a bit of a showstopper in my industry, plus others too, like financial and medical. They have similar requirements for auditing. And as Michael and the team had alluded to earlier in the conference, one of the problems I believe that we face is that this file system is available on multiple platforms. So with Linux, I was looking at Audit D, but I couldn't figure out a way to make that work correctly with SMB and NFS. So that was a bit of a failed effort there on my part. But anyways, Cumulo and Isilon, they make this very easy. And I've showed, I should have probably pasted a clip of the example of the logs that come out of Cumulo or Isilon, but anyone who's used those are familiar with what I'm talking about. They'll show you everything that you need to know. And it would be good if ZFS could implement that at some level. I don't know if the consensus is that's a higher level protocol issue to deal with, because I'm not sure how Cumulo and Isilon handle that themselves, because it's a proprietary closed system. So that was basically one of the things that I when I have my meetings with Michael and whatnot, that was like one of our roadblockers of recently that I discovered. And I guess I just want to bring up the talking point about seeing if that's something that's possible and how difficult that is, or just general thoughts on it.
More usually the Mike 4.
Okay, thanks. So here's the issue with that I think our friend is having. The normal system, operating system audit functions go through syscalls. NFS does not. NFS goes directly into the VFS layer, unless you're using like some weirdo, user space NFS. And so there's no mechanism at present to say, hey, NFSD, please audit everything you do. And in fact, one of the problems with NFS as a protocol is that it doesn't traffic in file names at all. It has these weird opaque things called file handles that it hands around.
And I think, like you
so-
said, it goes directly into the VFS layer where it's like a
Yeah.
vnode on the FreeBSD
Y-
side.
y-
And so
yeah.
the kernel doesn't have a file name at that point either. And
Right.
it's hard to create an audit log about who did what to a file when you don't know the file's name.
Right. Now, I mean, I think depending on your SMB implementation, you might have that information available there. But for NFS, it's just a really, really hard problem.
Well, I think even with SMB, you have the problem of the username is not the Unix username, it's the Windows domain username, which maybe is in a format where the audit system is going to see it, but maybe not as well.
If it's POSIX, you're good.
Yeah, but it's probably mostly domain /username.
Right.
But yeah, the NFS and not having a file name easily is an extra tricky bit.
But
I was not aware that the MPAA was going to have those kind of audit requirements, but I suppose when you're talking about, you know, attribution and credit for creating stuff and copyrights, it actually does make sense.
it's more of who viewed this, who could potentially leak it.
Mm.
That's the origination of the MPAA side of it.
Recall that North Korea owned Sony a few years back, and leaks happened, and people were cranky about leaks, and now they want to know through almost a remote session who is doing what to what image, how and when, and you name it. So yeah, that's the new MPAA Trusted Partner Network, and thank you, Greg, for your patience. Somehow Wi-Fi just went out to lunch. So key highlights, I guess, to recap for Greg. Again, always
The
at the
OS
higher
level auditing should provide most of this, but the problem is NFS is special and goes around the syscall auditing and goes directly into the VFS layer. And at that layer, it's all file handles and vnodes, and we don't know the file name of the file handle. And that makes things that much more complicated.
So do we need a mapping system around that can map it all the way to the file GUID to the all the way to the
Trouble is, you'd have to do that in real time.
right.
Because obviously, you know, file could be deleted or renamed and you wouldn't know.
That's
Yeah,
what VFS is doing for you
yeah,
under the covers.
Well, when you, at the higher level, when you do the call, it maps the name to the vnode, but once you've done that, there's not an easy way to go backwards. Because, you know, you can have a vnode that's open for a file that's been deleted. And so there is no file name for that file now, but you can still read and write the file until you close that handle.
And maintaining that state is something that needs to be recorded to be audited.
Mm-hmm.
Right, you could potentially have a, you know, auditable NFS implementation that kept, you know, a gigantic table of all the file handles that it's ever handed out and what paths led
Or
to
just
them.
extend its concept of the file handle to cache the name from when
Yeah.
it was open.
And then the question is, where does it make the most sense to put that functionality? You put it at ZFS side, you leave it at NFS, or you have another layer watching all of this stuff and merging it all
Yeah.
together.
So, I mean, so I think, you know, I mean, I agree with Alan that the right place is in the operating system. Although I can see that I can see an argument where you might actually want to have the file system, you would want to have ZFS do this, and in particular because that means that you can keep your audit trail with the data that it's about when you move it around, or, you know, if you export.
Right, or if you have
My
HA.
I need my snapshot. My snapshot contains the history of that file
Right.
access.
Mm-hmm.
If I roll back the snapshot, I still need the original access. Right?
Well, and then you should clone the file system and roll back the
Again,
one of them.
Those
Yeah,
are all the
yep.
workflow
Mhm.
scenarios in an audited
Yep.
environment that we need to maintain.
Yeah.
So yes, it
So
is,
that, yeah,
it is ugly.
there may actually be a better case for doing it in ZFS than I thought, based on the fact that NFS kind of goes around what the operating system already has, We want it to be the same on BSD and Linux. And also ZFS has a bunch of other stuff that we probably should audit in the same way, like all the stuff that goes in ZPool history. Somebody created a snapshot, somebody released a hold, and so on.
Destruction of a snapshot is an auditable thing.
Yeah.
All of those things tie into the story.
Because, you know, for a while I've thought about, you know, someday ransomware is going to get smart enough to delete snapshots. And so I want releasing a hold to optionally require two-factor authentication. Before we release this hold, you have to, you know, do two-factor so that it's, this snapshot doesn't get deleted unless somebody definitely was allowed to do it. Yeah.
It sounds like that would be like a feature setting to enable some sort of file locking confirmation.
Yeah.
So quick question, at the POSIX level, does ZFS know what a user is and who did what?
So ZFS does know, your mic's not on.
I'll repeat the question from the audience, which is me. At the POSIX level, does ZFS know what, who a user is working on a file, or is it just pushing blocks around as requested by
so ZFS does, and that's how it does per user quotas and things like ZFS user space, where it can instantly calculate for a whole data set how much space each user in that data set is using.
Okay.
And like if you do ZPool history with the extra flag, I think it's -I for internal, it can actually tell you which user on which host did each of the ZPool history actions. It records that always, it just doesn't always display it because, you know, most of the time you assume it's all this machine, but if you have an HA environment, it could have been the other node. But yeah, the history has a number of drawbacks. I know Delphix added an option to not record all the snapshot creates and destroys in the ZPool history because it would flood out the more important events they actually cared about. But it's still an auditable event, so maybe we need a limited ring buffer of the snapshot creates and destroys and still have the buffer of all the other stuff so that we can have some history, or maybe it's just better that the audit logs keep track of the snapshots creates and destroys, and ZPool history is more the other bits. Because, you know, yeah.
Just have something as a different ring buffer.
Speaking of syslog, has anyone seen a close tie of be it the ZPool history to syslog and everything goes over here and hope we add whatever checks and safeguards we can?
You can make the ZFS event daemon or ZFSD record the ZPool history event every time a new history entry gets created.
On Linux?
So, yep, on Linux or FreeBSD.
Okay.
So in FreeBSD, you have to add some config to devd so that when it sees the event from ZFS that a new history line's been added, you can log it to syslog. So you can just, it'd be, you know, a couple of lines of config file to make it log everything to syslog. And, you know, if you have your syslog going, shipped off to another machine and archived forever, it would then at least have all of that in it. And not in a ring buffer that's going to get paged out by people doing other stuff.
Yes. And then you read that back to the data set so that you have it preserved nicely in ZFS.
Yeah, your remote syslog server uses ZFS, obviously. Right?
And bring it back to the host so it's there and portable with it.
Or, you know, FreeBSD's...
Yeah, exactly. You bring it back home to say, oh, here's my log.
Something really interesting that FreeBSD's audit system has is audit distd, which is about sending the audit logs to multiple other machines in a way where we can verify, even if this machine got compromised, we know that the logs that we sent out to 4 other machines, they communally can determine that, no, these logs have not been tampered with.
Do you see much of that in the wild?
It doesn't create the ZFS. Not quite blockchain, but it predates blockchain and that silliness, but yes.
Do you see people using those audit mechanisms in the wild? And if you sat down a user at the Linux one or the FreeBSD one, would they recognize what they're looking at, or it's a complete retrain on
so OpenBSM is a standard that was used by Solaris, Mac, and FreeBSD.
Okay.
Only people in regulated industries have I seen actually using it. And it turns out jails complicate things a little bit because we don't allow you to set the username for the audit trail from inside a jail. So a jail can't fake somebody else, but it means that everything done in the jail is attributed to the user who started the jail, which is not necessarily right. So normally when you SSH into a box, SSH can call this system call to say, I'm now this user, and attribute everything that's done in this session to that user. And we don't allow that from inside the jail so that they can't fake somebody, but it means we kind of inherit some state and misattribute everything to somebody who maybe the last person to restart the jail days ago was, the secondary sysadmin. And no, everything that happened in the jail is not their fault. So that's one we're working on fixing right now.
So back to prior art, we have the user space accounting. We have a few things where the user is actually acknowledged and ZFS gets to care. Are there any other prior art examples of ZFS caring about a user at the POSIX level and higher?
Well, just obviously all the VFS stuff and the ownership of a file. On Linux, we have the username munging that you can do for namespaces, so that if you have different like LXD containers, they can have their own set of users that get mapped to a different set of UIDs, but inside the container they all look like, you look like your UID 1001, but to the host you actually look like your 1,000,001 or 1,000,001, so that on disk in ZFS the owner of that file is not just user 1001, it's 1001 in this particular container and not that container. And that way on disk the files don't show up as being owned by user 1001 on all my host systems is Alan, but whatever's inside the jail, who knows what that is.
Sure.
And not conflating those UIDs can be helpful. But as far as the auditing system goes, yeah, ZFS doesn't currently have much of anything, and maybe it should. I've also wondered about if it should adopt something kind of like FreeBSD's mandatory access control framework, where the permissions were more flexible. Like ZFS allow is pretty good, but there are maybe more ways it could be expanded. And some things I'd be looking at are like, right now, ZFS destroy is a permission, but there isn't a separate permission for you're allowed to destroy a snapshot but not a data set, or and so on.
Granular role-based controls.
Yeah, and so most of the ZFS allow covers every ZFS subcommand and every property, but it doesn't cover the fact that some subcommands are overloaded, like destroy.
Oh, destroy. Oh,
is a data set. If you're allowed to, like, you can say only this data set, but you can't say only the snapshots of this data set.
Does Solaris do any of that stuff with their RBAC?
I don't know. Not that I'm aware of, but I don't have a lot of experience with Solaris. Does Andrew know more about Solaris?
Andrew.
He does not know about if RBAC covers any of that.
Greg, while you have the floor, go ahead and unmute. Does that help? You have to unmute. Okay, go ahead, Patrick.
Just so everybody knows, when he's talking, we can't, so we gotta do a over,
Okay.
call over like you're on the radio. Okay?
Yeah, it does. Unfortunately, the audio was coming in and out, and it started oddly looping back our sound check from 20 minutes ago. So I don't know what's going on there. But yeah, I will. You and I will sync up, and I'll just get the Coles notes off of there. It sounds like there's perhaps a solution. Anyway, yeah, I just want to flag that as that's what has been preventing us from going full in on it until there's a solid solution for auditing that type of stuff. That would have to include things like just not SMB and NFS, but if somebody were to SCP to the machine a file or whatever, we'd like to capture that as well. I think that's included in the description of requirements. Yeah, exactly. In case somebody gets on the machine itself. But yeah, I'd be interested to see it, a solution for it. Whilst it's and I agree that I think it is an OS more than a file system issue. The higher level protocol should be able to, you should be able to extrapolate that out of them. I think the correlation of them and whatnot is a bit of a thing too. But yeah, we'll see. Like I said, I am very stoked to be able to use a ZFS solution as opposed to something that's 5 times, 10, 20 times the cost. And the the support is the killer part when you got to pay that. So it's quite steep. But yeah, I think that's really it that I had on that that was my big concern, and as a group and a company, that's where we said we can't go forward using this, even though it satisfied our technical requirements and our throughput and our round trip times on NFS calls and whatnot. Everything was great. We even had support. We had Honey Badger cards in it from a company called Liquid. So everything was on NVMe as far as metadata and cache and logs go. So the system was stellar. Continuously was saturating links to dual 25 gig links to one server. So there was no performance issues there. But it all came down to the auditing, which was a big thing. So that's where we are.
We'll close this and jump to the remaining slides and points. Go ahead and jump on the normal stream, and thank you so much. Good luck with the game tonight.
Oh. Or maybe they can lose, not 5-1 some night.
There's a distinct possibility he had the stream going in the background.
Yeah, left YouTube open in a tab somewhere.
Yeah.
Explain getting feedback from a long time.
Give me just a sec here. I'll find my little
NFS should be
tab screen.
auditing.
You can dummy me, whatever.
It would simplify upstream life significantly.
Yeah.
Yes.
And the alternate is a lot of hats that are very risk heavy.
Yeah.
We can unify NFS at the SIF layer, you know.
Okay.
Database stuff too. Here's my database backer. Whoever saw it.
Yep.
I've got the keys to the kingdom of HIPAA in that database backup. Oh, it was read 3 times by 2 locations we know. What's the third?
Alan, anything to relay from Stu?
No.
Okay, cool. So we've touched on a few of these topics, but completely orthogonally, but kind of related, is metadata traversal performance. We were talking about in the last session about, okay, we can get this information cheaply, this information at a great cost. And someone pointed out that, hey, for example, in libZFS, which we will talk about later, there was some zero recording of ZFS history with BECTL on, I believe, FreeBSD.
It might be worth checking if ZPL history-I as an internal doesn't record those anyway. It just doesn't show up by default to avoid automated actions kind of flooding the log.
Okay.
But yeah, the ZPL history should be creating on the kernel side, and so it shouldn't care whether you did it via libZFS or not.
Got it.
But yeah, so if it's still, if it's not recorded even in the internal log, then that is a bug and we should fix it.
Sometimes I see on Truna's site, I see logs of ZFS pool and some messages, probably ones generated by libZFS, looks different from everything else. And I have strong feelings that it's almost like voluntary logging things. Like I've done an action and separately logged some log record. And those two don't exactly match each other. So history cannot be exactly trusted. And that's not very good, despite that logs are sometimes corrupted, just syntactically wrong sometimes. But again, if they are not written by kernels, then how can we trust them?
Yeah, for sure.
is this a documentation question? You should use your OS native auditing, or we do have issues with NFS bypassing it and doing clever things that are opaque to the auditor.
Yeah, I don't know the answer. My biggest question is, you know, what are the other solutions doing? Like, I understand there's the commercial solutions that we can't necessarily know what they're doing, but it feels unlikely that there's no media company that's doing, you know, generic Linux somewhere and somehow meeting these requirements. So what are they doing differently? And maybe it's not easy to get the answer to that, but it does sound like you can probably get some level of what the MPAA requires from Audit D or something.
So some of the answer to that also depends on how expensive do you want to make searches of the data. Because, for example, you know, NFSD could simply, you know, be made to write a trace of every NFS op that it does, just leave out the actual data. And if you had such a trace, you could reconstruct what it had done, provided you only have to do that, you know, very rarely and not on short notice. Whereas if you need to have something where, okay, the auditor has shown up and I have 3 hours to demonstrate exactly who and when this file was accessed, that potentially requires a lot more work in terms of being able to remember the names through which handles were accessed over time in memory, and then creating appropriate, and in stable storage too, and then creating appropriate audit records in real time that reference the name rather than the handle. I could see how to do it. I have, you know, unfortunately, as you know, part of the course of turning into the storage guy, I spent a lot of time digging in the innards of the NFS code and yelling at Rick Macklem, and it's certainly doable. I think it's the sort of thing where, you know, if you had like a summer of code student who wanted to do that in an NFS implementation, that maybe you could get something that would show you where the holes were that you then needed to pay someone to do a professional implementation for.
Well, and you also have the cost of, I mean, just straight Samba cost, it's a 60% overhead to turn auditing on to the level that is needed there.
Yeah.
So if we can get that at a lower level, even if ZFS does it and it's 20%, that's still a win.
Have you tried the Samba audit level versus the OS level? Are they feature parity, performance parity? Where any advantages either?
The Samba level is the one that gives the detail that you can get to.
Okay.
And then an auditor needs, if they're actually looking at it.
Do any of the other SMB implementations have that level of auditing, or purely Samba, to our knowledge?
MoSMB does.
MoSMB?
But it is ugly. It's got some features, but it's something we've tried.
Okay.
I don't know anything else that is.
I mean, this is another question where I have to ask, what does the Solaris kernel SMB server do?
Exactly.
I know a guy though.
Yeah, so auditing's implemented in the Vino layer. So what happens is when a session is created, as far as I understand it, an audit context is created which captures certain information about, you know, the user IP and stuff like that. And that's what's used to basically record or, you know, generate an audit event. So as far as I know, it's they're standardized. So you get like, you know, open, read, you know, stat and all the general file system kind of, POSIX file system operations. And, because they have an in-kernel SMB implementation, which is just using the same, internal, it's essentially doing it like, read and writes, but like instead of the system call, it's doing it like directly. So yeah, so as far as I know, it handles that fine. And as far as I know, it also works for NFS. Yeah, and SCP or whatever.
Someone mentioned eBPF. Does dTrace help us? Do you magically have a probe that says, everyone did this, here we log it, have a nice day?
Not really. As they were just mentioning, that context that gets created when you log in, that's the thing that FreeBSD jails doesn't let a jail set, because I think at the time it made sense, but I think now, as long as the audit entry says it came from inside that jail, we'd actually rather that it could set who did it. It's just
interesting.
The username it gives has to be namespaced to the jail, which is not something audit did before, but it has for more years on FreeBSD now. But I don't know that it creates one of these user session contexts when somebody connects over NFS.
It does not.
It does not, and that seems to be the root of the problem, is that we don't have this context of who the user is when it's something that's happening over NFS. And maybe it's something we can look at a little more and see.
Yeah, so NFS basically passes a Sun RPC version of a struct ucred. So it has credentials. It doesn't have names. Well, in NFS v4, now it does have names, except if you have Linux clients, because they like to send numbers instead of names. But I think you have available to the NFS server all of the data that it would need. It's just a matter of, it's really expensive to collect and store and manage this data in the NFS server, and typically most NFS implementations are judged on the basis of performance and not on the basis of how much of your RAM can they take up with audit records.
True. Yeah, and that's why I'm wondering if maybe this might be like a product future for OpenZFS, because I know in my experience, deal a lot with ransomware hacker and ransomware situations where you get a customer asking you, we had 700 VMs that were deleted. I want to know when they were created, what time they were created, who deleted. And so not necessarily every transaction in the cases of a lot of the customers I deal with is needed, but something like that at the level of file create, file delete, file move operations, which are not as expensive as some of the modify change all the time, but that might be a possibility to consider as a future.
Yeah, so
spoke earlier, the MoSMB with Active Directory and debug mode. That's why it's annoying. So it does collect the data, but it's in a debug status, which is painful to parse.
whereas with OpenBSM, there's a tool called Audit Reduce that lets you kind of filter down the audit trails to just what you're looking for. And in the work we did 5+ years ago was teaching Audit Reduce to be able to say, I only care about the audit logs from jail number 4 rather than the whole system, and being able to just look at those traces and also just not conflate something that happened in jail 4 with something that happened on the host at the same time, because the user IDs in the jail don't mean the person on the host did it, right? There's a separate user database.
Well, multi-tenant, someone deleted something, could be 10,000 users.
Yes, so yeah, user 1001, yes. If you don't specify which container it's in, then that's a different user in every one of those containers.
Any final thoughts? We're at 20 minutes after. And if not, I thank you very much, and we'll reconvene in 10. Welcome back, everyone. This is the last session of the day. It will be our least formal, and we've been blessed with Matt Ahrens and George Wilson, among other people trickling in. I hope your flights weren't delayed or anything. Cool. So I was calling this I Learned, Show and Tell, and War Stories. And it's a pretty fair game. I have a very quick This I Learned to kick it off with, and I've got a war story that we can save if we're needing to fill some time. So this I learned. You can do things like ZFS list-t snap for snapshots, which is awesome. There's a shorthand. And then I thought I'd do ZFS allow Dexter snap to allow snapshotting. And it's like, you're crazy. I'm like, let me try it again. And you do need to spell out snapshot when allowing. And it hadn't occurred to me, just as a user, that the shorthand might not apply everywhere. And I believe based on a conversation online or on a Type A trained platform, Rob Norris kindly allowed for ZFS list-tfs, short for file system, because typing all those characters for file system was a bit over the top, although there is snap for snapshot, etc. So the thing I learned is just to be verbose on all but listing when using shorthand, and hopefully that shorthand will trickle into all possible operations naming such things. There we go. There we go. Other stories, and this I learned. Yes, sir. Gary.
Oh, okay, this is just very short, but in sort of the same mode, I always get used snap and snap used backwards or reversed. I hope someone is going to fix that someday, or at least make them be aliases, because also, like, you have to type it one way and ZFS list displays it the other way.
I learned something today, actually, because it's something I was just only trying to do it on my laptop, which is why this manifested, because obviously it's smaller than most production systems. So I'm like, okay, let me just make, 10 disks, small size, and just kind of set up a mirror pool and, play around with it. Well, I did that, and I tried to create the pool, and then I started getting this cannot label area, trying to, I could show you the error. And I'm like, that doesn't make any sense. And so I didn't label the disks. I ran ls block, that there was no partition. I just added the disk, it was fine. And so I couldn't find anything on the internet about the specific error. And then I talked to Alan, and he was like, well, how big are the disks? I'm like, I just made them like 50 meg, and he's like, well, the minimum disk size is 100, so.
64.
so that's why I got that very nondescript error that I was stuck on for about 20 minutes, so.
Understood.
I'll throw it up on the internet somewhere, so next time somebody else comes across it.
Just a reminder, 64 megs, but our team, we were investigating an issue with ZFS where at some point pools were not imported. In some cases, appeared that if you have before ZFS on a file system, on a partition you had some other file system, ZFS on Linux in block ID appears after other file systems. So block ID first sees labels of ext4 VMFS, who knows what, and after that the pool import doesn't see anything. So, and while investigating, that's one issue, and obviously that's probably gonna stay, but at least we found that implementation of block ID, of probing of ZFS labels is not the same as one used by ZFS native. So Amir Hamza from my team is right now rewriting that part to hopefully make it work slightly better. It is consistent with kernel.
Yep. Rod had asked if anybody knows the history of why 64 megabytes is the minimum disk size.
For the slop space. For initially, like when we did Z-test and some of the testing utilities, like you needed so much to run the tests, or they would fail. And so, and I think it grew over time, because I think 64 meg was kind of what we found was, sorry, so it actually kind of stemmed from some of the testing that, that was actually implemented for ZFS. And to get the test to actually run, because when you create the pool, you have like so much kind of slop space that we keep around. And so we needed disks that were big enough to allow you to be able to like run tests and still have enough space for like all the metadata that we maintained.
And to copy and write all that metadata.
Yeah. So we kind of landed on 64 meg, but I seem to recall that at some point in time we had to increase it because there were other tests that started failing, and we ended up going with a larger size. But
I think it's the same problem.
yeah, it was the same problem. It was like as tests kind of grew and different functionality came in, we just needed more and larger kind of small disks, and that's why. Although I swear at one point in time it did tell you the minimum size, like it wouldn't give you a cryptic
I think
error.
in this case they were 8 megabytes, and by default ZFS on Linux tries to create a small reserved partition and then the ZFS, and that one needs to be, I think, is 8 megabytes, and so it couldn't actually create the partition it was trying to create because it was bigger than the whole disk.
Didn't get that far, yeah.
But yeah, there are quite a few times where the error message, you know, because error nodes generally have one text description, it often isn't actually telling you what the problem is.
No, I was going to say it would be good if there were some more uprintfs in the code that basically let you know when you were trying to do something stupid that ends up, you know, when it comes out of the kernel just as, you know, enval or whatever, because there's a lot of different things that all map to the same erno, and if you don't know which thing you're doing, I mean, it's, you know, it's like Ken Thompson's editor. It's, you know, you do something wrong and it just displays, huh? And it, you know, there is information in there that would tell you what you did wrong, but there's just no way to pass it back across the regular, you know, syscall API. So,
well, I think my favorite example of that one is generally the way the error is formatted. It has like the command that gave the error and then thing. And so if you have a shell script with an invalid shebang line, it says bin.sh file not found. It's like, but bin.sh is right there. What do you mean bin.sh is file not found?
I have a support horror story. Oh, Halloween's coming up, so, and we've got some candy back there. But yeah, yes, my phone will do that. So there was a user with an early Proxmox system, and on ZFS naturally, and they did everything right. They had a nice snapshot policy, and they retained snapshots for 6 months, diligently. But there was, hopefully it's gone, a bug in Proxmox that allows you to delete a VM. And they deleted an active VM that happened to be their mail server. But the OS held on to all of the resources for 9 months, and they finally found a service window. So after 9 months with a 6-month retention on snapshots on a VM that's diligently snapshotted for 6 out of 9 months, they finally did their updates, rebooted the host, and asked each other, where did the mail server go? It's just gone, because finally the OS released all those resources, and had they kept it booted and known, apparently through the virtual file systems, they could have probably reconstructed through all the stuff in Linux with virtual file systems and said, this is my backing storage, let's make a copy to somewhere. But no, it diligently cleaned up, and they scratched their heads with all this free space. Ooh. Bless you. Other stories? And Grill Master in back. Santi, how are we doing on the barbecue?
Just flipped the baby. So, you know, it's going.
Going, cool.
Got a hot date or something?
We, when did you wanted it for, you said 9 o'clock?
9 o'clock Eastern,
Yeah,
right?
Hey, you're Eastern.
Slow and low, right?
6:30 is, it's gonna be sausages for the people who get angry earlier.
Okay.
And or the people who don't get angry earlier, they can also have sausages.
And I trust we have leftovers from lunch, just in case someone just got off the plane. Okay, we had taquitos for lunch. Tito's Taquitos, they were quite popular. Other stories, questions, ideas, t-shirt slogans.
Oh, I had an idea for a meme just now. That's what I was talking
Oh, please. Do you need a mic?
You know the Mr. Incredible one? I could probably yell.
Right.
I mean, it's not that.
You can't yell to the internet.
You can't yell the internet.
You can yell on the internet, not to the internet.
Has everybody seen the,
That's a long one, yeah.
has everybody seen the, like the Mr. Incredible memes where it's like Mr. Incredible's face normal and then like black and white and like saturated? Or it's just like, oh, we freed up a bunch of space. Oh, we freed up a bunch of space.
Yeah. Boom.
That was
the
not,
good news is.
Thank you for the effort.
But, you know, my other meme that's similar to that, I mean, it would be something along the lines of, it's one of my favorite quotes for anybody, like, we're all about the same age. I would like to get that meme of like in Top Gun when he said, you know, where'd Hollywood go? Like, where'd your data go? Where'd what go? You know, I think that would be a really good one.
So I actually wonder if anyone has had to deal with discovery and finding out that they had snapshots that they weren't intending to keep that now they have to give to somebody's lawyers to sift through. Because occasionally, like, our snapshot policy fails to delete things that it's supposed to delete.
My primary snapshotting technique is kind of stupid and does run into that problem, but I haven't actually met with the lawyers on it. So, and the only time that I've had to deal with it broke in my favor because similar situation where somebody deleted something and needed it back further than what our official window was.
Does anybody actually have lawyers go and be smart enough to be, oh, let's look at the snapshots versus I'm just going to be like, you know, I need to find and tar everything up. And I've had them ask before. Interesting.
Had they heard of ZFS?
They weren't asking about that. They were asking for any available files related to this during this time frame.
In any state at any time.
So whether it was on tape, whether it was in a snapshot, whether it was on somebody's CD-ROM under their desk, that's the discovery width they were asking for.
I hadn't encountered that, but I had encountered once the opposite, when at the end of the case, the lawyer needed to destroy all of the data and not have it anymore, but didn't want to lose everything else that was in the snapshot. And it's like, that's why you need separate data sets.
I do have a customer that does regularly have notification for lawyers type of stuff, and they ask for the opposite, and they say, do not delete this snapshot because we will have lawyers coming and looking at this. So,
So
holds work great.
Yes.
And export clone. This is potential for legal. It goes into a different thing and it's only managed by 2 people. That's how we manage that policy.
Are there any lawyers in the house?
Who would admit to being lawyers?
Any success stories where, you know, for the win? I'm sure some of you have countless ones, but.
I mean, I'm afraid I've already like given away almost all of my war stories earlier today, so.
That's okay. You've got some new audience members. But.
Yeah, so, you know, and the big success story, which has also been kind of a pain for the last, I guess, 14 years now, was, you know, our old NAS equipment, which was Blue Arc, and I think some people still were trying to keep some NetApps going, was end of life. And, you know, my group was asked, how can we not have to pay $500,000 to replace all the storage that we have? They had been, you know, there was a history of like some random, really random like Linux servers, and before that, Sun servers, which tells you how long this history goes back, that people were unhappy with the performance of, which caused them to buy like the specialized hardware in the first place. But nobody could really tell me like what were these workloads. But since one of our industrial sponsors, a company you may or may not have heard of called Quanta Computer, they like make half of the hardware that you use in China. They gave us a bunch of hardware, including a platform that they had originally developed for Korea Telecom, which was half a rack that was a 2U server, and then 4 24-bay JBODs with a SAS, SAS interconnect. Thankfully, I didn't have to deal with like any RAID cards or garbage like that. So I said, hey, we have FreeBSD expertise. All my FreeBSD systems run ZFS. This seems like it would be an ideal platform to run ZFS on, particularly once I put some SSDs into this storage array. And we did that. And then I became the storage guy, which was not really my intent because I'm the network guy. I already do 3 jobs. I didn't need a 4th job, but that's how things work out when you're small and nobody wants to spend money on infrastructure. So even when in the future we had to actually buy hardware instead of getting it for free, it's still like a order of magnitude difference in cost between what we can buy or what we can tell our researchers to buy is closer to the truth. And even compared to some of the more economical platforms like the TrueNAS platform on the hardware that IX Systems sells, we're still like half of the cost of that. And most people are happy. The people who are unhappy are people who are not really using the file system very effectively, or at least they're not using NFS very effectively. And they're unhappy about performance, even though even on our oldest servers, they're really not getting anywhere close to exercising the full performance of the server, just because like their Python scripts are shit, excuse me. And that has worked out pretty well. We're now on our 6th or 7th generation of hardware, because we've expanded from 1 server to 4 servers, and then now we have about 20 plus or minus. There's some that should be going away, and we mostly get them from white box vendors that we like. IX Systems has generally been pretty competitive for those, but we have another vendor that we also like to give some business to because we want to maintain that relationship and if there's no difference in price, it's like at some point we have to give them some of the goodies too.
Spinning disk or flash?
Sorry?
Spinning disk or flash, or both?
Almost all of our stuff is big spinning disk. Our most recent build was 60 22T drives, because that is kind of where the market is right now. We don't want it to be any bigger in capacity because our users can't really fill it. And particularly if it's going to go to a single user, which is how most of these things get built, they really, it's 560 terabytes. I should mention we basically stopped using, we were using RAIDZ 2 in our initial build, and we've gone to 100% mirrors.
Really?
Because, I don't ever want the user to come to me complaining about performance and have it turn out to be, well, 3 years ago you didn't build this pool with enough VDEVs. And okay, well, I can just give, what is that? That's 28 VDEVs of 22T drives, gives you 560 TB bytes, to use the IEC terminology. And mostly we're pretty happy with that, except for how it interacts with our old backup system, which we've basically, a lot of the users have said, well, if it's going to interact that badly, then we're just not going to back up our stuff. And it's like, well, okay, so long as I have that in writing, then that's what we'll do. We obviously can't do that for everything. Some stuff actually has to get backed up. But, it's really worked out pretty well, and it's saved people probably on the order of $2 or $3 million. Although, okay, so one thing I did learn recently that I just remembered, ZFS list, is it ZFS list? No, it's ZFS user space uses the incorrect prefixes for user object used. It uses the binary prefixes. And objects are not inherently power of 2.
Yep.
I noticed this because df-I disagreed with what ZFS user space was telling me.
That sounds like a good hackathon project to fix.
Yep. That's it for me.
Yeah, I don't know if it's really a war story, but I think that the craziest thing I ever did was ZFS. Had a customer, it was a university that had a distributed file system built on top of ZFS. And so they had 24 different pools across different machines and a complicated HA system to fail them over. But the one thing they had never considered might fail as part of their HA system was the switch, the network switch. And so when the network went down, their HA system decided that the other node was down and that I should import the pool on this node. But every single node decided that it should be the one to import. So all 24 pools were dual imported on the A and B head for at least 45 minutes, taking turns overwriting each other's Uber blocks.
That's LOTF failover.
Yeah.
That's Lord of the Flies failover.
Yeah, very much lacking a shoot the other node in the head mechanism. But we managed to get most of the data back by rewinding the pool to different levels of different transaction groups and getting back different data sets and a week of craziness. But there was one data set where all the data was fine, but not the root directory, but one of the subdirectories under the root was corrupted. And that one, all it contained was the one directory that then contains all the files. And it was gone. There was no way to get it back. And so I wrote a little, the Linux equivalent of what a sysctl would be, where a tunable that when you write to it, it runs a function. And so you echo an inode number into this tunable, and there's one tunable that you set a data set, and the second one you write an inode number into it, and it reconnects a file with that name and that inode number into the root directory. And then suddenly the files are accessible again.
Lost and found.
Yeah, basically a manual lost and found mechanism for directory entries. And that is the dirtiest thing I've ever done in ZFS.
Well, we're at 5 o'clock. I think we can just take it easy until food is ready. If you're starving, we've got leftover taquitos we can warm up. We have countless beverages. We have a pen board that is available for, say, grouping rides back to hotels, or designing the next generation of real-time replication, or something, something, something. Or that list of hackathon topics, which I hope are in your head, Alan. You've been saying, that's a nice bite-sized project. I don't know if they're on a spreadsheet somewhere, but
Did
anyway.
Matt get a spreadsheet put up? Oh, yeah.
Yes, sir. It's
Fill
up,
it out.
I believe linked. And there will be shopping replenishment runs. If there is something you want or desire, please put it on the board there. Vanilla creamer came up, and we obtained some vanilla creamer, along with pens for the pen board, because I don't know where they vanished. We had one little one, so we got that far. Many of us are local. Some of us will be on site. We have cables, adapters, power supplies, laptops, you name it. JBODs, if you desire some hardware to poke at, just maybe put it on the old whiteboard there. And I've got an Epic server with 2 NVMe slots. Alan, you've got those 2 NVMe drives that were on sale, and he had me grab Canadian penalties. If anyone wants to hack like that, well, everyone in this room guaranteed has some resource they can bring to the table. So this has been informal and fun, I hope. Any feedback? We doing okay? Okay, awesome. For food, tomorrow is, let me think. Tomorrow is Fat Cart. You'll see the names fly by on the side walls. Fat Cart is a fusion bento up. They have a food cart up the street. They started life as a food cart, became a restaurant, and it's really yummy and one of my favorites. So they'll be then Monday Thai lunch, and we have the pulled pork and tofu gluten-free augmented dinner courtesy of Stu. Tonight is Santi on grill. We have an Argentinian barbecue. And hopefully Elephant's Deli tamales for Tuesday lunch. Sunday night, you'll be on your own for the countless options in Portland. I think I promised a list, but there are countless lists out there of all the wonderful places to go. If you have some oddball desire, just a quick search will find it, or I can help you with that. Or help you identify what part of town some neighborhood is. Is it close? Is it far?
Or if you need some relative of ours and that's a restaurant.
There you go. And some of us have wheels if you need a ride anywhere. And kicking around in the kitchen is a list of lots of stores, and like mostly food places, but hardware store, Best Buy, you name it, sorted by distance. So there are quite a few options within like a mile and further and outward. So I want this to be as easy and productive. And the keys to the building are in my pocket and Rod's pocket. If you want to hack late, nothing will stop you short of the Multnomah County rule to be quiet by 11. But you can be loud in here, and we have a great sound system, as Patrick and I verified. It's like, so, yes, sir.
Just if anybody wants to stay late.
Oh, we've got some deodorant. We were thinking a spray gun might be appropriate if anyone. There are 2 couches there. I don't recommend sleeping in the church and back, but if, well, no one will know. Anyway, any questions? Anything? I say we just take it easy for the next. Go ahead. Yes, sir. Yeah, okay. Welcome. Thank you.
And thank you, Michael and crew, for doing all the org work.
My pleasure. Yes, the crew has been awesome. I will do it from memory. We had Nick, who is not here today. He had to run home and do life things. Patrick on audio video. We brought him in from New York, and I'm very glad we did. Thank you, Patrick. We've got the pit crew, the pit grill crew of Santi and Stu. I believe the Freshes had to head home for the day, but they've been invaluable. They're local. They've been picking up food, ordering food. That is Andrew and Lisa, wonderful people.
Save the applause for when they're here.
Yeah, save the applause, save the applause. And Rodney's been helpful, helped set up last night. We've got him as our resident, let's see, previous life emergency responder to some degree. We have a new first aid kit in the kitchen. The other one, someone noticed that there may be some eBay items we could get a good price for. We also have a licensed Oregon and Washington State bartender here 24/7, just out of pure coincidence. Thank you, Stu. So, yes, sir.
And a very well thought of.
Yes, once the stream stops, I will explain what's going on there. Are we still streaming?
We can jump right now.
Okay, thank you everybody on the stream.